Okay, we're live. Hey folks, my name is Balu. This is Amit. We are from Upside Industries. We're going to start the event soon. I mean, the event's already started. So Amit is going to just. I want to thank Force United for the collaboration, and the event we're doing. I'm just quickly going to hand over the mic to Amit so that he can give an intro on what Upside is and stuff. So, Amit, yeah.
Hey, how many of you here? How many of you here have opened a toy of something that you own? Hands up, come on. Nice. How recent was it? When was the last time one of you did it?
Amit.
Fair, my bad. Okay, this we don't need right now. But the idea is that when I was 8, I used to open my toys, right? And I would look inside, and everything was magic, right? Everything just worked. But none of it I could read. There were no parts. There was no way of actually reading the circuits. It was a complete black box. Magic, but I couldn't access it. And I, as an 8-year-old, would go, how does it work? Like, how does this thing work? And the thing with curiosity for me was that, it's weird. We are currently at a time in reality where we've gone all the way from the caves to Mars. We figured out quantum computers, right? But our products come with expiry dates. Like your products literally could be built to last decades, but they're like, let's kill it in 2 years. Space grade tech, like things that could last hundreds of years, die in a year. Why? It's anti-human. If you think about it fundamentally, we have X amount of resources, and we're burning them for what? So the idea is simple. We try to move everyone towards open source hardware. Why? All the problems that exist still exist in the open source realm, but at least you can look at the schematics. If something goes wrong, maybe you could modify it. Maybe you could repair it. My bigger ask would be, have you ever had a product go, but you didn't know how to fix it? And you loved the thing. It worked, but there's no way to fix it. Hands! Hands! Look at yourselves! Look at each other, look at so many of you. That is the idea of absurd. From our perspective, if you're someone who's working on open source hardware, or if you're someone who's already done it, we want you to come and show it to us. We're also trying to build a platform. We're trying to make people sell their products. And the best way to support hardware is by buying open source compared to closed source. So that's what we are. And my thing is, from our perspective, one ask that I would have is, whenever you make a thing, just consider that. What part of it can you contribute to? I mean, you have to speak in the mic. My part. What part could you contribute to? And if it comes down to it, let it be open source. Welcome to the hardware Devroom. Should we introduce the first?
You can. I have a very quick firefighting to do. You can just do this.
I'll take it. Okay, thank you, Amit, for that. I'll talk a little bit more about Upside in my talk. But yeah, I think the first speaker is Shree sir. He's firefighting right now. So in the interest of buying some time,
No, it's okay.
do you guys want to hear a joke?
Yes.
A cannibal is someone that goes to the hotel and orders the waiter.
Oh my God. Balu started with that. Balu, another one. Another one.
Yeah. Come here.
I don't know. I can't think of any joke after this. Nobody told me. Oh yeah, by the way, we are running a sale right now on CoryDoras. So if you guys want one, please come to the Upside booth and buy the CoryDora and other products as well. I'll in my talk, right? If you guys tell a knock joke to me, you will get a discount if you buy the CoryDora. Anyway, the first speaker is Shree sir. Sir.
All right. Sorry for the disorientation for a while. So everybody, can you see the screen? And I think everybody understands what this is, so I'm not going to tell you what it is. All right, so everybody welcome. Very happy to have this hardware Devroom here, which our folks from the absurd community, who are not absurd, have kindly put together, curated. It is very unique experience even for me as somebody who was helping run the conference because they opted for doing voting. So we have a very nice concept which is coming this time called Devrooms, where communities, independent communities are actually coming up and actually running the parts of the conference, which is like very exciting for us. Now, keeping my conference organizer hat apart, now I'm going to start talking about my project, which is called Jigita. Now, Jigita is like jump for Kannada, jump in Kannada, and it also stands for Jig Itta. Okay, so jig is something that people use to help do tasks, mechanical tasks. Itta is like again Kannada for do you have it, right? But by a curious wordplay, jig it is also make it a jig, right? That's what you actually see on the video right now. So just as a show of hands, we are in the hardware dev room, but I will ask this obvious question: how many of you actually do soldering? Oh, a lot of people are nice. Okay, so the hardest part and in soldering, actually any manual soldering, is in fact if you look at it, it's not actually not the act of making the joint. It's actually the task of holding the workpiece in the right place using the 5 or 8 or whatever number of arms that you have, right? And finally, when you are trying to tell somebody that this is how you solder it, actually you are trying to tell them that this is actually you hold it, but making the joint part is basically you take the soldering iron, have the right temperature, make contact with both the pad and the pin, and you put the solder, right? So that's like, everybody thinks like that's not a difficult thing. The difficult thing actually is holding the piece, right? And that's where everybody suffers, and you guys will be surprised to know that not just us, hobbies, you know, people who do it for time pass, business and pleasure, pleasure and business, not only do we struggle, but people in the factories also struggle with the same problem. And nobody is building tools for them, so this is like one such attempt. So this project, which is on GitHub, I'm going to like obscure this for a while. This is the project. It's on GitHub. So how do we describe it? Easy PCB assembly, no motor skills required, right? So most of the time, it's not really about making the joints, it's about. So how do we do that? We do that by building helper jigs. These helper jigs are 3D printed. So again, we'll go back here. The video is a little, it looks very odd. It's quite bad actually. So I'm just going to like take this out. So if you see here, so this is like a Pico, right? So everybody familiar with the Pico? Raspberry Pi Pico, right? So how hard is it to solder this? You'll have to find a breadboard, keep the two things. You could still have the pins like going cross, right? In spite of all of those things, you still have to be careful, right? What this does here is a very interesting piece. Actually, if you look at it, it's like precisely designed to the position of the Pico and to these pins. And it has exactly what you need. Now, maybe now you can see it better, right? So it has like the exact thing with which you can make this Berg header sit. Okay, apologies for the bad video again. But that's mostly the projector actually. So it has exactly the right thing to sit. And see how easy it is. So you just take this, right? You put this in. You take this, you put it in. And now you take this and you, it's my left hand, yeah. Put it in, now boom, solder, right? So that's how it is. So how was this born, right? So this was born by, actually I do very little soldering. So when I make these kind of tools, people start thinking that, you know, maybe I do a lot of soldering, which is definitely not true. I suck. My eyesight has become bad now. I use my DSLR as a zoom camera for soldering and all that, right? But that's my personal setup. You'll never see it outside. But the fact is, I suck. That's why I made this, right? So I was making one more board, which was this here. It's called, oh sorry. I hope the video does not disorient you guys. So this is a board that I showcased in last year's IndiaFOSS. It's called Ativega. It uses the microcontroller from CDAC. And this very interesting thing about it is it has about like 13 single pin Berg headers. And some of them are 2-pin, there are 8 1-pin headers and so on. And that's a nightmare to solder. And my hardware guy tried to tell me, you know, he said, Shree, this is not how we build it. I said, this is how a software guy builds a board, right? Every interface should be separate. Pins should be logical. I started giving him that long lecture, which I would have otherwise giving him as an architectural project. So he said, yeah, he smiled at me probably, right? So when the board actually came, guess what I was struggling with? Single pin Berg headers, they won't become vertical. I wanted to sell this board, I can't sell because it sucks. And somebody with my kind of experience doesn't want to sell a board which doesn't look nice, right? So all that happened and kind of, then I started looking at things. I found that with FreeCAD, the KiCad people have actually had started trying to do something like this, but they have all never made it very generic. So the key contribution of this project is that you give it a KiCad board, okay, which has 3D models inside it, and it will generate the 3D printable jig for you directly. You have to tweak something to do stuff like, what do you call it, tolerance. So let's say if you use a default tolerance of some 0.2 mm, then the components will fit very nicely. Depending on your printer, there's some dependency, but that's just one parameter that you need to tweak. Okay, you just tweak that one parameter, you have the right model, and boom, you get something which you 3D print, and everything fits like magic. Okay, so it fits that well, and you could do all sorts of things. And well, this is not theory, right? So I've been using it, and feel free to really check out this project. I'll show you some samples. Right? So basically, that's the 1, 2, 3 of this. So there's this video here which makes it easier for you to understand what's actually happening. You have a 3D printable thing which comes out of your design. You insert the components, which in this case are like those 13 Berg headers, and then you insert the PCB, and you are ready for soldering, right? And of course, soldering can't get any easier than this, right? So this is about as good as it gets. So, so the thing is, okay, so there's a Hackaday project page also, and it can be used in various projects. It's not just, I mean, that looks like that's a complicated little project for something like this. But if you really look at it, you will find that you can use it for, you can use it for a lot of projects which are available off the shelf. Now the thing is, I have not designed a lot of hardware. So one of the key problems for me was how do I make sure that this software is good, can work for a lot of people. So what I did is I went around finding community projects. So for example, Pico itself didn't have a KiCad layout at that time. I don't know if it has a KiCad layout right now. But there are community very similar looking footprints, exactly form factor compliant boards. So I used them, and I generated this thing. So it's a script which just runs, and back it will throw a 3D model at you. So there's something called a Pico glitcher board. So that also has a lot of pins, you can see. So they also have other connectors that does it. This is the granddaddy of all soldering projects. Okay, so basically like any interface that you want is there inside this. So somebody's built this kind of a crazy board, and you can imagine how they are going to put it together, right? I tried building it. My software is generic enough to handle it. I've gone, zoomed in, and checked that the kind of model it generates is perfect. Of course, I haven't tried it, right? Because remember that involves soldering and getting that board and all that, right? So I haven't done that. Then you can actually use it for doing fun things. So we typically build all these tools. Tools should never be single purpose, right? So what is one of the craziest things that you can do if you have a 3D printer? Well, you do a lot of 3D printing, right? Start finding solutions with 3D printing which otherwise should be solved in other ways, right? So what are the crazy things that 3D printing people do? You know, all sorts of things. Keep running you bought the printer, now you have to run the printer 24/7. That means your whole life has to revolve around 3D printing, right? And scheduling the printer so that it keeps running all the time. So in this case, you are into electronics, you are into 3D printing. What do you do next? You build containers for your favorite things to hold them. And containers for what? Bug headers. Right? So you can use bug headers, and well, it's not really limited. You can use KiCad. Use 3D models for Allen keys and build Gridfinity containers for Allen keys, right, using it, and it's all parametric. So it's very interesting, by the way. If you go and see all the Gridfinity, I don't know how many people know what Gridfinity is. All right, basically Gridfinity is a 3D printable generic container template. So there is like a huge project. There are a lot of contributors to it, and what happens is people come and say you can have screw boxes, you can have screwdrivers, you can have all sorts of equipment. For everything there is some Gridfinity model. So it's based on a 42 by 42 mm grid, and you can really build big projects with it, right? So if the thing with Gridfinity is this tries to emulate the thing that you see with tools. So if you see with tools, they are built with ABS molding. So what really happens, you have a rectangle, inside that you have like a hole in which something sits, right? But with 3D printing, it's vested. Why is it vested? Because you have to print that whole thing to the height. What you really need is something which will hold it, right? And this project is exactly that. It adds extra stuff which just holds the Allen key, and it has like notches where you can actually pull the Allen key out, right? So one sec. I'll zoom it in. I'm not sure if it's clear. I think this will make it clearer. Does that make more sense? So you have like space, you can actually pinch and pull out the Allen key. Okay. So yeah, getting started, we have a page, and let me show you guys something else interesting. Okay, so there's a demos directory. Oh, what exactly happened? Oh, it's demo, not demos. Okay. So one thing I'll mention here is another theoretical project right now. So we have a board called FOSSDEM audio board. It's used for audio capture. In the FOSSDEM conference, the largest FOSS conference in, I think, Europe, maybe the world, I don't know exactly. So basically give it this thing and it'll split out the whole thing. But the fun thing is, if you really look at it, let's see if this has those examples. So typically if you search around online, what people have been doing, they've been building molds like this. Okay, the one which you see below is basically wastable. It's wasteful in terms of the kind of plastic that it takes, right? It's solid. It has hollow only where the components have to go, right? With this project, you can build those. Plus, you can build these kind of sparse structures, okay? So you want to do something industrial, do something which is like, tagada. It's like, it has like, it's big, it's hollow, it has hollow pockets, right? You want to do something for one-off use for like 10 boards or something like that, do something which is sparse. You're in education, you're trying to teach somebody something. Why would you want to sit around printing the whole solid thing and then put cavities inside it, right? So don't do that. Just do this. So that's actually illustrated here. Let me switch off. So when I showed you the Pico, I showed you guys this, right? So basically, if you really use this, it uses this much plastic, right? The other equivalent of this is just this. Oopsie. Can you guys see how that's going to work? Alright, so you're like, take the header. I'm sorry for the shaking camera. One header. Oopsie. Two header. So it's exactly the same thing. Yeah, and it prints very quickly, it consumes very little material, you could build an entire environmental story around it, but I'm not going to do that. Right? I mean, 3D printers are just those kind of people. Hey, let's print the heck out of this, right? So I'm like, no, just think about it. There are plans in the project, by the way, to do like, maybe with origami. So some of you guys may know Amit here, he's very interested in origami. Influenced by him, I bought an origami book, which I never read till now. Right? But one day I'll come to it. And I think, for hobbyist purpose, there's no need to like 3D print a lot of the stuff. You could do it with origami. Use your hands for something useful. productive and kind of like exercise your brain also, rather than like control P and send it to the printer. So roughly that's, if you actually go to the project page, you'll find a lot of details, like for example, how much grams of material can you save, what are all the 100 properties. Like many things, you can export to OpenSCAD. That gives you a parametric model which you can tweak on the fly using the sliders. So it has like tons of these features which I don't want to go into, but they're there. And most important, I will tell you that I've been doing some commercial projects with this, which has shocked my friends, me also, because the biggest problem with so what's the ultimate use of this? Can this be used in factories, right? So of course, we solder, I don't know, what we solder in in like 1 year, they probably solder in 10 minutes or something like that, right? I have seen them work. Okay. So I was trying to figure out if this can be used in factories. Then I spent time prototyping with a single company which is in Banchankri. It's a single line electronics factory manufacturing. They do a lot of manual soldering. And turns out there are still good reasons why people are doing manual soldering. Depends on the kind of components you have, the kind of volumes. There are like many considerations. So when I showed this to them at one of the conferences, they were just right out. So I was giving a talk, and their booth was right outside my that room where I gave the talk. So they immediately latched onto it. It's a small concern. So I went did a project for them. They were happy, but that project didn't run long. That means that I didn't get much money, right? So then I was a little worried whether this can work or not. Then they came back with another project, which is kind of also start-stop, but at least I'm sure that I'll make a little more money. In case you're wondering what is little more money, it's probably going to be like 60,000 rupees over 6 months. And the biggest challenge with all these people, as you might imagine, any Indian company is like getting the payment. You can raise the invoice. But when will the payment happen? That requires another expert. But regardless, what I will say here is the efficiency of these people has gone through the roof. I am surprised. When an Indian vendor tells you, the Indian customer tells you that your efficiency has increased 30%, you should be sure that it's at least 50 or more than that. Right? I mean, that's exactly how price bargaining, price negotiation works, right? So you ask somebody, how is it? If he says very good, then that means that your value will go up, right? So, so that's the fun thing. But the most unexpected thing for me, out of this project has been, which I never expected. So there are a lot of women which are who are employed in the factories, and they are like, wow, this really works, this is amazing. Because they all ultimately, they set targets, right? They have to meet targets, and any tools are welcome that way. Ultimately, it shows in their contribution, right? So I did 100 votes today, will become 150 votes tomorrow, right? So they'll, in the beginning, I will get some credit. Later on, it'll be like it's part of the process. So I'm just trying to make it happen that way, but it's fun. I have to still find ways of scaling this, but of course, the entire project is open source. But I have to say this: not every technique I use in the factory floor is actually in this. So it's like not exactly open core, but it's like that's the part of the business that I probably understand very well. So when I go work in a factory for like a month or something like that, I probably understand how they work, what kind of structures work better, what materials work better. If they throw solder also on it, will it survive? What material to use, right? So all those kind of things are probably but most of the thing which any hobbyist, anybody doing small prototyping can use this. Industrial probably like you need something a little more robust than this, which probably I mean most of the thing which is already open source does, like I think 95%. Yeah, but that's the thing about industry, right? It's always about that last thing which makes things work. So I have something which I do as a some code which is not maintained in GitHub, but otherwise is very active. If I find out bugs, I fix them there. So I think how are we doing on time? Oops. 15 minutes. Oh yeah. Okay. Huh? Oh yeah, I can do that. Yeah, I think then this is a good time to. Yeah. Where's the other piece gone? Yeah. So that's okay. Don't worry about it. You can pass this also around. Actually, I have like a whole bunch of whole box if you want. Yeah, here. Just make sure it all comes back. So this has all the various structures, a lot of things. Yeah, because quite small, right? It's a little harder to show. This also you can.
That was the one that's without
That's
optimizations.
yeah, it's not without optimizers. Yeah, this is a very similar this thing also. Yeah, it's the same. So that's what roughly the project is. You can use it. Uh, I did a workshop on this in one other conference, and the healthy thing that came out of it is I made it work on Windows. So that script is also there, so it can be used. It's still a command line tool. I have a plan to put some uh, front end with graphics, with a graphical front end kind of thing. No, it works with capacitors, transformers, resistors. Yeah. Correct. Generally, what happens is if you know exactly which one it is, you do that. In my case, my work with the factories, you know what happens? I have to reverse engineer the board because they are given the task only of soldering, and they say, "Hey, sir, this is a sample, sir." Right? What do you do on top of that? So then you like quickly figure out what to do. Because they will not have the entire BOM and everything, and even if they had the BOM, those guys won't be maintaining 3D models. Nah? So if it's like 0.2 or 0.3 mm difference, what will finally happen is that everything, the post-soldering result will not be that very good. So if it's a first person design, that's always very good. Yeah. One sec, hold on. There's even a mic somewhere, I think, if you want to use it. There's a mic here. Yeah, sorry. Sitting right here.
Guys, everyone who took the jig, just pass it over to Harish, please.
First thing, I like the names you give your projects like Jigita and Hativega, and yeah, if I have to name something next time, I'm going to contact you.
Certainly.
So
Thank you.
that said, I was about to ask. You said it's a CLI tool, right? So
Uh-huh.
is there any possibility you can make it like a website? You know, like people
Oh.
don't have to download anything; just come to your website, they upload some file, and they.
Yeah.
Yeah.
Okay. In fact, quite interesting question. Because when I first showed it to our folks here in Absurd, right, the first question they asked was exactly this. You know, hey, you can make some money out of this. Put this on the cloud. You know, it's not invalid. Probably right, but it's a little more complicated than that because then I have to start. Okay, I'm not a web guy, and you know all that. I hate maintaining that infrastructure. That's one of the things. And I wanted to like study the problem from a practical perspective because ultimately it's not the hobbyists who will pay for this kind of thing. You know, maybe there's some industry. Hobbyists can probably spend some time figuring it out, and that's what I've been doing. I've been prototyping it with the factory, and sometimes nowadays when I attend other events, I go it with the eye to see what are the kind of components that these guys are still using on the boards, which otherwise I'd be thinking, you know, what is the architecture of the board? I'm a very senior embedded systems designer. That's what I would look at earlier, but now I'm looking at what components are used inside the board, how are they placed, right? So I think there is maybe some scope, but the interesting thing is, yeah, it's just too much to expect right now that it work out of the box for the ultimate intended user. So for an engineer who's designing their own boards, they already know what is a 3D model and whatnot, right? So then if they make some mistake, they know how to fix it, right?
Yeah.
But for a generic person, if you provide such an interface, they'll start thinking that no matter what you throw it at it, so the garbage in, garbage out principle they will forget. And they'll blame the tool for a mistake which is not the tools. So this commonly happens in electronics. People change components, so many things people do, right? And then, I mean, I've worked for like, I don't know, 12, 13, 14 years I have never been a hardware designer myself. I can call myself a hardware designer, but the implementation is always done by very experienced people. So, but they are sometimes very lax about these kind of things. Some of them do it very well. But ultimately, garbage in, garbage out still applies, which is the trickiest thing. So.
Yeah, got it. Thank you.
Any more questions? Okay, we have one there. Okay.
Have you tried it with pogo pins? That's especially useful for testing, flashing, those kind of things.
Aha, great question. All right. Let me think of how to. Actually, some things I didn't show in the interest of making it simple. One of the concepts is basically that you can slice. I mean, think about it, right? So, in a lot of the designs you have like big vertical thing and there's plastic in the middle. So basically there's another mode in which you can operate the program. You can cut the middle and you can have like screws and then you can like compress it. So it's already provided for in this tool. It's a very roundabout way, by the way. But that thing that you're asking whether when the pogo pins will come and press, right, that's already provided for. It already handles mounting holes. It can provide spacer like mechanisms. Actually, some example might even be floating around in that box. But it's possible. It's not exactly like a directly supported feature, but it's implicitly like built in. So.
And in that case, a follow-up question, but in that case, if someone is using pogo pins and a clamp, will the plastic be able to take it?
Oh, yeah, that's all out of the, that's a like mechanical design, right? So that's not in the scope of this. It probably allow you for doing variable spacing and then you put a spring and you push it in and you have like a little mechanism, then it will make contact. So 5. Any more questions? You have one.
Hello, sir. This is a really interesting idea. So I want to ask, you showed 2 boards, 2 3D printed boards right now, one for the Pico and one for another board.
Yes.
So I was wondering if it is, so for these boards you have to create that design, for each individual board, you would have to create a design, you would have to create a jig for that individually. If
Yes.
you were to
You
follow
would
this
have the
process.
design as part of the engineering process.
Yes.
Yeah.
So I was wondering if it would be possible to create a sort of building blocks kind of implementation, as in because all the ports and pins are kind of a standard size. So maybe if you could have like a base like for building blocks and then each port and each pins, like you can create, you can
Great question. Great
you can
question.
make a lot of, you can do for whatever board you have, right?
Yeah, yeah.
So-
Actually, it's a great question. I'll try to put a different spin on this because I have thought a lot about it. 2 aspects, right? For every board, should you have a different jig? Correct? That's your real question. Now, if you really look at it, let's say you're into soldering bug headers, right? Bug headers have certain characteristics, right? They're all like roughly the same height, right? And you'll have many of them in different places. So instead of, oh, actually, I don't have that example. Yeah, apologies. So basically, the idea is that I have it somewhere. I think it's an example. One second. Let me find this out. This is a good question. This is a good question. 1 second. Pico soldering jig. Yes. Oh yeah. Sorry. Oh, okay. Sorry, it's not there. Basically, you have this thing where you can make just a single thing, and you can have a variable height thing, and it be solid. So you can have as many of them placed like a Lego brick. Then you can push it in. So that exists. I am not able to find it now, but it's very much possible, and you can tailor it to the way you want to see it. You say that this is the height that I typically work with, and then you just make one bug header holder, and you can just move it around everywhere. And anyway, fitting it is not a problem, right? So the whole pattern will match. All right. So I think we are out of time. And thank you very much. Any more questions? I'm around in the conference. Maybe I'll be busy today, but definitely tomorrow is going to be a relaxing day. So thank you, guys. Done? Yes.
Yes, you can do it. You can take your laptop, sir.
Yeah.
All right. Thank you, Shree sir. That was a great talk. Like Shree sir said, you can meet him after the talk, and you can connect with him for more questions. Just
one last plug. I don't know, maybe a bad idea for a conference, which I'm finding out. So I've been thinking of running a potluck. I think it's still open. I don't know how many people have said they will bring something. Idea is to meet for lunch tomorrow between 1 to 2:30 in that room. Like there's a small workshop room upstairs. So anybody interested? I'm not saying, but it's just that's why I call it. It's not shameless in this case. It's a plug. That's all. So if you want to get something, just go to the forum. It's just a side event. If you want to get something, do get. It'll be a fun thing. Let's see.
okay. Thank you, sir. Yeah, folks. I don't know, clap, I guess. Right? Okay, because we have a little bit of time, to all the speakers here, Michael, the guy in the red specs, will raise his hand at the 10-minute mark and the 5-minute mark. So just keep that in mind. All right? Michael, just hold your hand also, right? Okay, so the next speaker is Shadow. I know, we all know him as Shadow, but his name is Giri. He's an 18-year-old genius, I guess. He's has his hands on everything else. And we'll do another joke. This one's a knock-knock joke. Okay? Knock, knock. Oh, shit, I forgot. Let's do it again. Knock, knock. Who? This is the sound of the police.
Chinese who?
Okay. Shadow, come on. Let me know if you need anything, okay?
So hello everyone. I'm Shadow. I'm not Shadow. Wait. So I'm Giriprashad. So I'm a 18-year-old student. I'm a first-year mechatronics student. So I love hardware. Basically, you can know. So I'm a game developer and a 3D artist. So I basically use Godot, Blender, and now I stopped using both for some reason because I'm exploring low-level systems stuff. So I have been learning C++ for like few years and OpenGL. So for those who don't know, OpenGL is a like low-level graphics API. You might have seen those in like drivers or like when you're installing some drivers or games. So I'm also like passionate about hardware and tinkering, and I build games without engines right now. So before we go, I have few questions. How many of you play games? That's still less. Okay. How many of you are like new to hardware, like beginners? Okay. So like, have you started to learn? Or like yet to start? So like, people who have started to learn, have you faced any roadblocks in learning? So maybe, what kind of, if anybody wants to tell their experience, there's somebody there.
Just the sheer lack of documentation and sometimes how confusing data sheets can get if one exists.
Okay, understandable. So the problem. So I have been like building a game called VoltQuest for like past 4 months, and it's basically because electronics is difficult. So the problem is that electronics is fun but difficult to start. Resources are just some thick book with dry theory or some non-existing documentations and data sheets. And beginners get overwhelmed before they start. So what is VoltQuest? So this is like an open source educational game which I have been building. So you basically drag and drop components, build stuffs, and learn electronics in a level-based system in a fun and structured way. So why VoltQuest? So you might like ask, we have Tinkercad, we have OakV or CircuitVerse, lots of simulation tools. But the thing with these simulation tools are that they are not really like focusing on education. Like if I would compare it to like giving an ID to someone who doesn't know code. So if you're like having Tinkercad, let's say for example, you don't know what is a capacitor or a diode, and you're like gonna build a circuit. So without knowing the like fundamentals or like learning the stuffs, You can't do stuff. Okay. So this game focuses on like teaching the fundamentals and like learn, since this is like a game with levels, the learning feels rewarding. So how the game works? So you just like pick up components like batteries, resistors, build circuits inside levels. Like it works like there will be like, let's say it has chapters and levels. So in each chapter, the first chapter it could be like learn electronics or like introduction to electronics. So in the first chapter you will have like 10-15 levels, which in each level you will learn. First level could be like series parallel circuit, what is a open circuit. So it is like it will have animations and like a character with dialogue explaining how it works, how it does, how your circuit works, how to debug it and everything. So that's how you get instant feedbacks and progress updates in the game. So the game is like still a work in progress. It has been 4 months and it should be here. So this is the like prototype I have been like building and testing. So it's basically a Tinkercad clone right now with a basic physics engine. It's custom built. So you can like build circuits, reset this, connect. You can add resistors, adjust the values of resistors, everything. Okay, wait. So what's under the hood? So this game, as I said, I have been like exploring low-level system. I have used like libraries and just C++. So there is a library called Raylib, which some of you might know. It's a really popular game making library. It's open source too. It's a simple and easy to use library to enjoy video game programming. It's based on like OpenGL. It uses OpenGL as its backend. You can check it out. And another library which I use is like Nano SVG, which is to like pass the SVG files and the textures of the game and rasterize the textures real time, so it gets scaled and like not blurry. And the JSON library which I use for like levels and like settings, configs, everything. So what's the like impact and what's the point of this? So this brings a bridge between the theory and practical stuffs, makes hardware fun, accessible. It's a gateway to electronics. So the roadmap right now is make 30 levels, and the platforms are like Linux, Windows, Mac OS, Android and web, and release the game, which is kind of optional. Now wait. So before we go, since I have been like building this game for like 4 months, and I just built like assets, everything like alone. So if you're like interested to like contribute to open source, like contribute to this project, you can like check out the GitHub. And I also created a Discord server for this. I'm sharing the QRs here, you can scan it. It has the link for the Discord servers. Okay. So as I said that I have like built most of the stuff from scratch, so the code looks like this. So I have like level manager, screen manager, so texture manager, UI manager. So everything like each thing is like individually managed and done from scratch. So that's a like simulation engine for this too. it does like nodal analysis for the circuit. So each circuit, so if you see this component, the battery has 2 pins. So that's a positive and negative. So these are like nodes in the backend. In the like simulation engine, these nodes, like when I add another battery or LED, it analyzes and every nodes and like check if this pin is connected to this pin, how much voltage is going to this and this, and Kirchhoff's law, Kirchhoff's voltage law and everything. So basically the physics. So the origin, why I started making this. So as I have said, I am like more interested in hardware, and I wanted to learn hardware. But the thing was that all I had was some books, random YouTube videos, which was not really interesting or not structured. So I thought of like, why not build a game to make the learning of electronics, hardware easier and like better, fun. So like if you're interested to contribute, you can like contribute, join the Discord server. I might like post update in the future. The game release, I don't want to talk about it. I don't want to make any promises about releases. So any questions maybe? No. Okay, Mike.
Hello.
Yeah.
Like does the game also like educate on the components and everything?
Yeah, that's for the like, this is like whatever you have seen is like, this is for the debugging and demo of the like physics engine. So the actual game will be like, if you go to play, there will be a chapter menu, as I said. It will have like introduction to electronics, a chapter.
Yeah.
And inside the chapter, there will be sub levels. Like first level could be like, let's say like what is a battery. So the battery would, the thing, a robot, a mascot or any NPC with a dialog box in the like bottom, it will explain. Like it will first tell you to drag a battery, drop it, connect the like, the red one is positive and its anode, which is cathode. So it will explain everything like with the dialog system. And then the like dialogues, you have the dialogues which will be explaining everything. So after that, you will like also have planned like multiple levels, not just simulations. Like if let's say if the basic levels like how electrons flow. So in current we have two currents, like conventional current and electronic current.
Yeah.
So conventional is like positive to negative flow of current, and electronic is like the flow of electron. So electrons move from the negative direction to positive.
Yeah.
So like we can just have a simple like subway surf, not 2D subway surfer kind of thing,
Okay.
where the electrons just avoid collisions, go to the positive terminal.
Yeah.
So the gamification is not limited to just building circuits. So you will have dialogues, you will have, I will try my best to like make it fun and not just boring.
Also another thing, that presentation that you've made.
Yeah, that's
also made by Relip.
Yeah, that's also made with
That's
Relip.
really cool.
Okay. Yeah, thank you.
Any more questions, guys? Where's the guy?
Shadow,
Yeah.
how much time do you think you need for like version 0 for us to play?
Version 0. Well, if I don't have college, I might like make it in a month. Huh? I don't want to mention that here. It's in my LinkedIn anyways. So maybe like I'm planning for, I already like planned for a release in like August 31st or like September 2nd week maximum. But due to like I had like college, I'm in first year, so I have lots of stuffs. So I couldn't like manage everything and like work on the game. So I'm thinking of like doing it this in the side. Maybe like at least before, I don't want to say any dates. Before, let's say that it's September. Okay.
Yeah, so I have a little kind of physics engine question.
Yeah.
So let's say you have a 9-volt battery
Yeah.
and like a very small LED.
Yeah.
So normally when you do that in real life, the LED just burns out.
Yeah.
So do you plan on implementing a feature like that where
Yeah, it burns
you
out.
just
Like actually, it used to burn out. I didn't add 2 batteries because it's broken right now.
okay, okay.
So it burns out like it has a proper like simulation engine. Like it tries to replicate everything like burning off LEDs, dim if the voltage is like really low, like glow dim. So it tries to replicate most of the real life things.
All right, thank you.
Yeah. Yeah. Not yet, but I know the game. It's yeah. So any other questions? Yeah. Um, so for that we have like VoltQuest. So how many of you know VoltQuest? Okay, that's it. So I just don't want to reinvent the wheel. It's a open source software too, by the way. So you can like even simulate electronic components and even microcontrollers like Uno, ESP32s, Picos, everything. So let me just select this and some project. Let's okay. So you can like there are simulation tools which can be like used. There are already existing simulation tool. Some are proprietary like Tinkercad. So you can use this. I just didn't want to like reinvent the wheel. It was to like the game is to make electronics fundamental learning and understanding easier. So thank you and I end my talk.
Okay, guys. So we have Shadow finished his talk a little early, so I'm just going to use this time to talk a little bit about how the talks were chosen for this Devroom, which I think is pretty unique. I've not seen anyone do it this way. So it's a first, at least at FOSS. So at Absurd, we believe heavily in involving the community in whatever it is we want to do. So when the Devroom was initially proposed, we basically put out a CFP thing, and we had a lot of folks from within our community reach out. We reached out to certain individuals as well and asked them to apply. Once the window was done, we did something that I've not seen many people do, which is we decided to select the talks based on community voting. So what we did is we implemented a Amit, what's the domain? Okay, screwed. Right? So we basically had a community voting site that we built where folks from within our community but also outside the community could go register themselves and vote for all the CFPs that were present. Yeah, it's right here, right? So these were all the CFPs we received, and we basically had all of them. It was open for voting. The site was pretty secure, in like dual voting. We kind of we kind of considered that. We thought a little. Amit did a great job with the site. And basically, what we did is, at the end of the day, the talks that ended up getting selected were basically what the community voted for, right? I'm a strong believer in letting the community decide what they want, instead of having a couple of reviewers, do all the thing, which is, I don't know, which is I guess this is something unique. I've not really seen most events at this scale. Typically, there's like a reviewing committee who handles which talk gets selected, and in my opinion, I don't feel that often does justice to what the interests of the community. So in our case, pretty much every talk that has been given here was voted by the community, and yeah, I think that's great. We still have 5 minutes to fill. So does anyone here? What was the last component you guys fried? Anyone? Just raise your hands. Sorry? Oh, POE. Okay, that's an expensive fry. Anyone else? Okay, which one though? It depends. Okay, so he's winning. Who next? GSM module. Again, that's cheap, like $800. Sorry? You should have fried it. Tell me what it is. I'll decide. Nah, it's not counted. Next. IMX8. Okay. What's its price? Okay, I still think PO is like more expensive, so he's winning. Come on, guys. Nah, he's still winning. Next. I mean, it's still cheap, man. Arduino, which is it the original Arduino? Then it's $400. So next. Okay. Battle. Yeah, yes, please. Can someone help him? Right? Okay. I would say you guys, okay, actually he's winning right now. Next. Oh shit. Guys, we have a winner. Right? He fried his boss's laptop. Okay, let's move on then. Can someone tell me what was the, okay, let's see. This is a very silly question. Actually, it's not a silly question. Can someone tell me, I can't think of shit. Right? Okay. Why do programmers like dark mode? Why? Come on, man. Why? Come on, ask louder. Why? I mean, you're supposed to give me some answers. Right? Why do programmers like dark mode? Yes, because lights attract bugs. Okay. Okay, guys. Anyone here Homelabbers? Awesome. Do you guys have dedicated machines or just Raspberry Pis? I mean, okay, how many people here have NASes with them? Nice. Nice. Yeah. So you guys will love this talk. Jeff Gerling, how many of you guys know Jeff Gerling? Okay, for those of you guys don't go follow him, he's a really great guy. Makes nice videos. You good?
I need something to sit on over here. Mostly to show off, so it's okay. It's not important.
Okay. Okay, Kiran, you can start. All right, guys, give it up for Kiran.
Okay, I'm going to have a problem with this mic because I'm moving around a lot, but let's see if we can pull it off.
Hello.
Yeah. Okay. Hey, then how do I show anything? People can't see anything. Okay, what is the camera span angle? Is this covered? So here's the problem. The video will not have any of the talk then if... Can we move this? Yeah, can we pan the camera a little bit so that it's covering me over here? Yeah, it's good? Okay. So I'm going to talk about something very boring. There's something called a Raspberry Pi. Is this thing working? Not on? Yeah, now, okay, now it's on. So this is a Raspberry Pi. I'm sure everybody in this room has encountered one, but on the assumption that you have not, it's essentially like a desktop PC motherboard, except it is very, very slow. Okay? But also very, very small, fairly cheap. I think this is the Raspberry Pi 4. It's about 3,000 rupees. You can get one for as low as 1,700 now. And it's extremely low power. It can run at like 1 to 2 watts idling. which is something that a normal Intel or AMD CPU cannot do. Those things are like 5 to 15 watts minimum idling. And that kind of adds up when you leave something running for a long time. So one of the questions that you have when you have a device like this is, what do you do with it? You know, and there are lots of projects for a Raspberry Pi that you can find online. The best one that most people should start with is something called a Pi hole, which is DNS for your house. It removes ads from every computer on your home network, especially smart TVs. If you have not done Pi hole, you're missing out so much peace in life. So everybody should do that. Okay? Or if you want to upgrade, go to something like Home Assistant. That's kind of like Pi hole, but 10 times better. It automates everything in your house. So now, those are nice ready-made projects. But let's say you want to challenge yourself and say, I want to find something to do with this. Now, how do you find a pie-shaped problem in your life to say, here, this is the solution to the problem? And that's generally very hard to do when you're sitting at a screen, sitting at a computer. It's the kind of thing that, you know, kind of comes to you when you're chilling out. You know? No screen, daydreaming, and thinking of all the tiny things that are bothering you, and hopefully thinking, yeah, you know, maybe this is a thing that will help me deal with that kind of problem. So one of the things that tends to happen when you're in this ideal thinking mode of daydreaming is my computer's somewhere there. Okay? The moment I go there and say, oh, I had an idea, the next thing I'm doing, I'm on Reddit or Discord or, you know, Twitter or somewhere. It's a kind of thing that there is this problem which, how do you imagine a problem that you can solve with this kind of device, and how do you stay focused on the damn thing? Because the moment you go to a regular desktop setup and continue working, it falls apart. And so one of the questions that I've kind of been trying to deal with is, can I build a workspace where this comes daydreaming with me so that I'm not distracted when I'm trying to think about what is the correct way to solve any particular problem? So one of the ways that I've tried is, why don't you make a little phone mod, you know, and this is called a Hackberry Pi. You can buy it. I think this one is a discontinued model, but there's a new one which is based on the Raspberry Pi 5. I had one, but I forgot to bring it this morning. Maybe I can show it to you tomorrow if anybody's interested. So now this is kind of like a handheld computer using a BlackBerry keyboard and a Raspberry Pi. And now I can go sit daydreaming with my little cyber deck. It is so slow I can't go to read it, which is great because then I'm not distracted on a device like this. The problem I have though is, if you look at the backside of the device, it's closed off. Okay? And one of the nice things about working with an open hardware piece like this is the GPIO, that you essentially are adding on things to it and tinkering with it. And that kind of gets a little tedious when you try something like this. It looks like a bit of a retail product. You know, it again limits your imagination with what you can do with it. So typically when you start working with a Raspberry Pi, it starts looking like this. You know, that you got all kinds of things sticking out. It's a huge mess of wires. And that's not portable anymore. So once you're on your desk, once again, you get busy with Googling stuff and saying, hey, what's this GPIO pin? Hey, can I buy one more accessory? Once again, not thinking about your actual problem. So what I wanted was, if only I had something that was running on this Pi, but felt a bit like a laptop, because, you know, chilling out like this with a laptop on my lap, sure, I can do that. Okay? So I went looking for something of that sort, and I did find one. And I have a device here. Let's see if I can open it up and show you. So this is a product you can buy. It's roughly about 16,000 rupees if you can find supply, although it's completely sold out in India right now. And I have one. And maybe we can see it working. Now, this is a device that's like a laptop without a CPU. You bring your own CPU. It's a laptop without a CPU. I can't power it on because there is no CPU. Okay? What you get instead is USB-C and HDMI and USB-A. Plug in your device, okay? And effectively what it is that it's a monitor and a keyboard in a laptop form factor, but the rest of the device is yours. Okay. So now this is kind of great, and the way it is meant to work is this company offers you a standard accessory if you're trying to use a Raspberry Pi. And so it looks like this. Yeah. I have one of those. So it comes with this, and what I'll do now is I'll turn on my camera so you can see it on my laptop's camera. That makes it a little easier to see what's happening. Yeah. So this is like a little PCB accessory board. And you plug this into the side of the laptop, and you plug your Raspberry Pi on this. And then you got a Pi sticking out of the side of your laptop, like this. This, yes, I can sit here and watch and work on it until I start doing accessories. And suddenly, again, it's flopping out over the side. So once again, it stops being portable. So this one was frustrating me a little bit. So I figured, okay, why don't I try something radical that will potentially destroy this hardware? But you got to try. And so I did. And what I figured is, the back side of your laptop, which is normally stickers, what if I put it over there and stick it on the back? Why can't I stick my Pi on the back? Okay? And all you need is some kind of pegboard, you know? So like, put a Lego board, build a Lego, tower on the back of your laptop. As long as it's not too heavy, it's fine. So I tried doing that on this machine. And you can see it here. Yes. Here it is. So this was one attempt at solving this problem. Here's a Pi on a multi-board. All you do is there. So all of your odds and ends hanging off the back of your laptop. I haven't found a mount for the little thing still. So it is, now this is a little bit of labor. Like every time you got a new device, I need to make a mount for it. It gets annoying a little fast. And this can only take flat things that don't add too much bulk. Because the moment it grows in depth, I can't do this. Then it starts falling off. It will potentially damage my screen by twisting it too much. So this kind of became a dead end in that it's great for the first few things you try, but then you need to try something else. And so I tried something else. I kind of built a little table rack for keeping devices. Let's get on here again. So this is what's called a DIN rail. There's one in everybody's house. This is where your MCB is for your main switch. Okay? The switches, the trippers are mounted on a rail like this. It's called a DIN rail. You can buy it on Amazon. It's quite cheap. And all I did was take 4 pieces, put them on a frame, and now this sits on a table. Like this. Okay? This is not my design. There's a guy on printables called Iconic Fab who makes this design, and I just printed it. But you have power inlet. From there, I do what I want. So what I've done is, for my experiments, I put in a whole bunch of power converters. So I have 12 volts, 5 volts, 24 volts, or mains, depending on what I'm doing here. And you can make clips for all kinds of equipment. So I can make a clip for a Raspberry Pi, put it over here. In fact, this one's on a clip. So, oops, there it is. That's it. Okay. So now this becomes a way to experiment with hardware, except, but I want to sit here. And now what? Where's my keyboard screen and whatnot? So eventually I realized that this approach was a bit of a dead end, and I had to take on some other way of doing it. So what I figured is, okay, why don't we try server racks? Those things are meant for mounting equipment, right? And so I went looking for a server rack. Now, usually what data centers use is what's called a 19-inch server rack. That means it's exactly 19 inches wide. And if you want to know why 19 inches, you're going to cry. Okay? So it's not worth getting into. But effectively, somewhere in the year 1920 or 1922, some people decided to settle on their conflict about office space and said, your telecom equipment rack can be exactly 19 inches wide on the floor. You push it against the wall, next person gets next to that, and that's how they were renting out space. Okay? And it's got to do with how they build houses in America, where they don't build with concrete, they build with wood, and those wood strips are 19 inches wide apart. Okay? So it's a really weird standard. It's got nothing to do with logic. So I figured, okay, why don't I try using server racks? So I went looking for one. There's only one sold in this country. That is the smaller standard, which is 10 inches. And I bought one, and I'm going to unbox it for you. Here we go. So at this point, or at least 6 months ago, when I went into this, this was the only one sold in this country. And let's see what it's like. This is what you get. I added a few accessories. So I added a few accessories, but this is what it is. Okay? And so you can mount your equipment in these slots. It's a one-use slot, just like commercial data center equipment, except it's only 10 inches wide instead of 19 inches. Okay? Now, what do you think this costs? Yes. So, if you look at the way the mounts work, let's get to my camera again. Do you see this little slot over here? That's for a Raspberry Pi. Okay? And that's all the Raspberry Pi needs in terms of space. So what am I doing with all this space then? I mean, why am I buying a box this large for one Raspberry Pi? Just because there's only one available. Okay? And it costs 16,000 rupees. For what? It's just a frame and some nice acrylic. It looks nice. I mean, yes, you know, look at the YouTube reviews, everybody's raving about it. But what the hell? What does it cost so much for, and why do I need something this large? So this was a point where I forgot all about the daydreaming thing and said, you know, fuck it, this is offending me, you know, this cannot stand. So let's fix it. Don't trim it. You know, the emotion is required. So I figured, okay, look, you know, why don't I just buy some metal and make it myself? You know, what can it cost? And so what I did is I went to look at the 3D printing community for what they do, and aluminum is cheap. You can buy it anywhere. I'll show you a few. So these are what's called aluminum extrusion. You can buy this anywhere in the world, and that's largely because windows are made of aluminum. You look at the thing over there in the corner, the glass window is made of an aluminum frame. So aluminum is a commodity. As a metal, it is cheap. This kind of extrusion of the metal, standard, available worldwide, and this particular form factor is popular because of the 3D printing community, because they build the printers out of this. In fact, the cheapest source you can buy it from is over here. Misumi is a Japanese company. It's a wholesaler. They will not sell to a private individual. You have to be a business to buy from them. But if you look at the price, this is for 1 meter. It's a bit small here, but it's 270 rupees per meter plus tax. So that works out about 320. Okay? And this is a 1 meter of it. So I figured, okay, why didn't I just use metal frames and build that? But I don't want that much space, so let's do half size. So that's where my research began. And I wrote a blog post about how to do this. It's on my website. I don't think you can see the URL, but that's okay. You can, if you come to the table, I'll show you. Or let's see, do I have Zoom enabled? No, I don't. So sorry. It's jackerhack.ing. It's on the homepage. I have a link to it. And so this began my exploration back in March, saying, that's offending me. I want to do this for half the size. I have no idea how to work metal, so I'm going to see if I can buy it online by just buying all the pieces required. And so I built my first rack and documented all of the measurements and so on. This. Exactly this, but half the size. See? And if you look at the measurements, it's exactly the same. So this is roughly about 2 meters of metal. Okay? And if I had bought it from Misumi, that's 320 per meter. Twice is how much? 16,000 versus that. Okay? Obviously, that's not a full thing, right? You still need screws and stuff to join it. So it doesn't end with that little bit. But how much more can they be? They can't be 15,000 more, right, for screws? So, but this was not this price because I didn't know about Misumi at the time. And so because I had to buy from retail outlets, this actually cost me 4,000 rupees. Okay? But 16 versus 4, it's already victory, man. Why is anybody buying that? Just make it yourself, After all, it is just ordering online. You don't have to do any labor. So I started with that. And then one of the things I realized quickly when working with this is that I was trying to use some large equipment, and suddenly it didn't fit really well. And so I figured, okay, look, what do you do when you try to put a motherboard inside? Those things are not made for racks, so they don't fit the dimensions. So I tried different sizes to see what works for my purposes. So here's another. Now, this one is a server rack, but it's thicker. Okay? And that's because the material that I use there is 20 mm by 20 mm, and so it's called 2020. This one is 20 by 40, so it's called 2040. Okay? And that's the name by which you buy it online as well. So what I tried was, instead of 2020, I used 2040 so that my actual internal is still 10 inch. But I can slide something bigger inside from this side. Okay? And this again is 10 inch. So now suddenly I made it a two-sided rack where now I can fit in things wherever there's space available and extra long. But while I was doing this, I also realized that when I make arbitrary decisions like this, they are meant for one idea in mind, but I'm still in that daydreaming phase of saying I don't actually know what my idea is. It's still something vague that if I go in this direction, I will find something useful to do. So eventually I realized that because some things don't fit very well, and I'm trying to put them in somewhere else, and sometimes the dimensions are not right because I was not following the standard anywhere except one side. Because as it turns out, the server rack standard has absolutely no specification for how deep the rack is. It only specifies how wide. Because it evolved as a standard of saying, I want this much space against your wall, exactly 19 inches, because that's how houses are built in America. And you get 19 inches horizontal, vertical, unspecified. So everybody makes a rack of a different size. So then why am I following that guy's standard? I mean, that one measures 200 mm depth and 10 inches wide. This is two different units. So I'm also doing 10 inch plus 200 mm, okay? Because I copied them. But this felt a little like, this is just confusing to me when I'm trying to install equipment because everything is a different size. So what if I just make them one uniform size in all directions? And so I made a cube. Now it's 10 inches in every dimension. Okay? But it's actually not exactly 10 inches because there's a little quirk to it. And that is, if you look at the spec, Wikipedia has a diagram for it, of what is the actual spec for a server rack. Let's see if we can look at the numbers. Remember, they defined it as 19 inches on the floor. But when you're mounting, where is the screw hole? It's not on the edges, right? It's somewhere within its channel. What is the actual size? Guess. 18.312 inches. So it's an imperial standard in which they have 3 decimal places. Okay? You want the 10-inch version? 9.312 inches. 236.525 millimeters. That's the official standard. How do you cut metal to 3 decimal digit precision? Both of them, look, you do imperial or metric. It's 3 decimal places. Okay? The saw blade is 1 mm, right? You can't cut to anything less than 1 mm precision. It's going to be arbitrary, and therefore you will find that any equipment that is meant to be rack mounted has screw holes that are elongated, because no rack from any 2 different manufacturers is actually the same size. Okay? This is not 10 inches wide. It's about 10.5. Okay? It's just that the screw holes have to be somewhere in that area. So if that's the case, then why do I care? I will just round it off, right? And so I figured, okay, I'm going to round it down to 236, because if it is too narrow, it's okay, loosen the screw a little bit. But if it is too large, then I have to shave metal to tighten it, right? So it is easier to be slightly smaller than slightly larger, so it's okay, approximate 236. And the material that we're dealing with here, this is the shape of it. Yeah, so it's 20 mm wide, and the mounting column, which is this channel in between, is in the middle, which means that if I need to get to 236 with those columns in the middle, I have 10 mm on extra on this side, 10 mm on that side, which is 236 plus 10 plus 10, 256. Okay, and this moment I'm looking at it and saying, hang on, wait, 10 inches is 2.34 into 10, 234 millimeters. But by some quirk of the material I'm using, I have arrived at 256 millimeters instead of 254 millimeters. 256 is like 8 bits. This is very nice. It's like stroke of luck that I'm looking at the standard and saying, what is this? Randomness. Yeah, round it off. It doesn't matter. And I got a nice number. It just feels very satisfying saying that I've got a nice number that is just arbitrary, and it actually works because the spec is so vague. So I made it as a cube. Okay? And all of the things that I've done in the process of trying to figure out how to make this, I had to find different ways. So this was my first one, the small one there, the 4U rack size. Some of the second ones are also here. I went through all of the times I did the designs, like I tried to make the larger one that was actually 10 inch but using 2040, and you can see the smaller one fits in even though both of them are 10 inch racks. And to buy stuff, I went through everybody who's selling it online, the ones that at least I have bought from, and I know they're not fraud sites, because as it turns out, there are fraud e-commerce sites that nobody ever gets any money back from. So these are the ones I've actually bought from, and I've listed the prices at the time I wrote this article. The prices will have changed. So the Misumi one is the cheapest one of all of them. But if you go to SP Road, you will get it slightly cheaper as well. And you need a whole bunch of other equipment. So I kind of made all of these things. And then once I started assembling my equipment, and I'll show you a bit. So here's something I made. This is a 10-inch display. It fits on the rack. I can attach it. Here's my little computer. It's a mini ITX motherboard. Okay. So I can actually I can turn this into a PC case if I want to. And because I made it a cube, even though I'm out of space over here, I can put whatever I want over here, because the display is after all hollow. It's got nothing behind it. So now this is nice because I can stuff this as I like. I can effectively play Tetris with this design, use up all the space, except for one problem. How do I give this power? Now you need a power strip. So that became my next problem. So these are the commercially available power strips. This is from MX. It does not fit the rack. It's sold as a rack mount power strip. Doesn't fit. Why? Because they made it a few millimeters longer and they put a cable on the side which bangs against it. Here's another one I bought. Okay. This one has a cable you can insert later. Okay. doesn't fit. But I was looking at these modules and saying, hey, this look modular, Can I just buy those power modules and make my own power strip? And so you can buy them. Right? It's exactly the same one. You can buy it from MX. Okay? And it's like 60 rupees each. So I figured, okay, let's make one. So here's my power strip, homemade. And it fits. See? So my idea of making it like this is to put it this way in and mount it from the bottom, because all the bulky plugs that you get, which are for the European plug and not Indian plug in India, you try to put them horizontally, they'll fall off. You put them vertically, gravity will keep them there. So keep it like this. I've got power here, and I also made sure to put in this little piece of metal sticking out. Anyone wants to guess why? Earthing, it's metal. Okay? You don't want to kill yourself, and that's what's going to happen with one of those things. They have no grounding. Okay? So I actually got a technically superior design, which I can't sell for legal reasons because I don't have a BIS license. Okay? So instead, I can give you instructions on how to do it yourself. So it's on GitHub. Okay, so out there on the table, I have all of this stuff. You can come and inspect it. I also discovered in the process of buying parts, like buy from Misumi for half the price of buying from any other e-commerce site. Misumi is not the cheapest. I found better places on SP Road. But the thing is, when you want to buy cheap, you buy lots. And part of the problem is that this frame is about 2.7 meters. Okay. I can buy commercially 1 meter. Okay. But I can't join metal. I have to cut the full length. So what's going to happen is that those frames are 216 mm in length each. Okay. What is 216 into 4? It's beyond, it's almost at 1 meter, right? I'm going to have a little bit of it left like this much. What do I do with this extra piece? In every meter I buy, I'm going to have a little extra piece. So typically the way to do this is the factories that make these things make them in 4 meter lengths. And if you can get them cut at the factory, then I have very few of these extra small parts left. But I can't make a retail order and say, give me one stick with this many chops from a factory. So instead you say, please buy 40 meters at once or 50 meters. So what I did is I sat down one day with the calculator to say, given all my segment sizes and 4 meter lengths, how many of these do I need to buy to have the minimum wastage? I ended up at about 30. And so I bought 30 racks from a factory because they were like, a fraction of the price of buying a commercial one. And I use that for my experiments, but I have some spare. I think about 15 odd people have already bought my spares. I have a few left over from my first bulk purchase to optimize my price. So that's available if you feel like it, but that's completely optional because you can buy it all yourself. It'll cost you more though, because I've got the benefit of bulk discounts. Yeah. But that's it. Yeah. Not this one. This one is only 1 amp. Yeah, I have a better one that I've been working on. Yeah. Yeah. Oh, it's over there. Anyone wants to guess what this is? It's all of that in this. 100% of that in this. Yeah.
Hi. Yeah, that was very impressive. I just have one question. Did you solve your original problem?
Yes, that.
No, the daydreaming one.
So I solved one version of it. I figured out how to record a room like this in one box, which has audio, video, all of it pre-assembled. So it's easy to come in, plug and play, start recording. Takes about 45 minutes because the audio always is the venue's thing and not your thing. So you can't prepare in advance. But essentially, for me, as someone organizing community events like this was solving my pain of how do I show up in a venue without losing sleep overnight, and in the morning very casually set up and I'm running. Okay, so that was one aspect of it. That was not where I started. My original daydream started with trying to scan a few books and build a kind of like a L-bend scanner instead of a flatbed scanner, which is not done yet. But in the process of dreaming about that, I ended up solving this and all of this stuff.
Any more questions, guys?
So the idea was to discover problems. Okay, so the thing is that if you force fit a problem, the solution will never be appropriate. So it was more about saying, I need a way to daydream and not lose the dream when I try to implement it, which means that it's got to be, kit I can take somewhere and sit there, look at it, think about it, and say, hey, can I make this a little better? And then not have to go back home and do it, but do it right there on that. Not particularly cafes, but I walk to events like this, and improve things on the fly. In fact, I have a drill outside because I have to fix a little thing on this, which we will do once we get back to the table. Not yet. There are no batteries in it. All right, thank you, everyone.
I have a last question. Any plans of making it mobile, like having a UPS or some power source?
Yes. That was in the picture over here. Let's see. You see the thing there? It's a battery.
But yeah,
it's not in this yet.
Not
it's
in
still
this
on my
yet,
table.
But there's batteries of size of 10 inch, right? That you can put on the space that you have there.
Yeah,
it can last longer for maybe when you have power cuts.
So this one is lasting me about 8 hours.
Oh, okay.
Okay. So it's like, and it's just
Yeah,
318,
that works,
650. So it's. This is the nice thing about working with ARM. It's so low power. Like my idling on that machine, that's a rock chip. That's not a Raspberry Pi. But the idling on that is like 2.5 watts.
Okay.
Okay. So just with 18650 batteries, I can get 8 hours out of it.
Yeah.
So like, why do I need bigger batteries? This is at least flight safe.
Yeah. What about the ITX board?
The ITX board is also an ARM chip. It is not Intel.
Okay.
Yeah.
Makes sense. Yeah.
Any more questions?
Hi. Do you carry this around on flights?
I just brought them in here.
Okay.
No, but
How?
what I typically do is those, and that is the other problem I'm working on. So you will see that camera again. If you look at this one, you see these holes?
Yes.
Okay. No hole. So what I've been trying to do is, the moment I have some equipment sticking out of it, I can't simply keep them on top of each other because then it's on the equipment. So what I figured I will do is, let's see if I have it here. So you take a little 5mm screw, put a couple of nuts on it. Okay. And let's see, there's the other one. So now I just have to adjust the nuts to the correct size. And it stays there. Okay. And just do 4 of them. And that's my transport solution. And that's why I have a drill. Yeah.
Yeah. I think I myself have gone through this kind of rabbit hole. I started with Raspberry Pis to mini PCs to finally sticking onto laptop motherboards. But I have to custom print the mounts for this.
Yeah.
One solution that I am kind of looking I'm suffering with is like stacking and wall mounting. Like I want to like mount it on a DIN rail. Like, is there a possibility to mount the whole of this on a DIN rail and take it out and
Yeah,
put it
that
back?
is also.
Okay, so it's
That's meant for mounting.
on the DIN rail.
Hang on a nail, hang on a French cleat.
Okay.
I haven't done DIN rail yet because I'm not sure DIN rails can take the weight for this kind of load.
Okay.
But a regular wall hook,
Right.
the foot is meant for that. This one's ABS. Yeah. The one that goes below is TPU. So I have a few of those and the other ones. And the other way I've been dealing with this is, let's see if this opens. For the equipment itself, one of the things I've realized is that if I keep iterating to hardware, it's painful to make custom mounts every time.
Yeah.
It's easier to just do cable ties. And so I made my own design that, let's see if we can go through. And so basically what I did is I kind of made a Raspberry Pi size design, but I also made a generic grid of holes. Yeah. And this, you just put whatever you want, cable tie it down. And that makes it very easy to iterate and figure out what you want, and then you can make a custom mount for it. Right? Yeah, so more Q&A outside if you need to.
Let me have it.
All of it goes there because I'll put the sensitive on there.
We can take, no, we're on time, right? Kiran's talk went a little over time.
Sorry, yeah, I'll get this machine off. You can.
Yes. Macropad, yeah. Yeah.
Kiran, one of your. Yeah, something fell off.
Yeah, I've been had my eyes on this from that time.
Okay, let's go.
Give me. Go down, I'll give you an hand over. One by one. Okay. All right, guys. Thank you, Kiran. It was a good talk. So now it's time for my talk. Just before I start, by show of, sorry? Give me a sec. Sure. Take your time. Let's see. Schrodinger's cat walks into a bar and doesn't. Oh, that didn't hit. Okay. Yeah, smart people will get, bro. Okay. Why was the math book sad? Because there are too many problems. Okay. By show of hands, guys, how many people here know keyboards? Like, I just want to understand before I start throwing around terms. How many people here understand what some terms mean? Can you raise your hands again? Okay. So most of them knows. Okay, so I'll try to keep it. There are a couple of hands that didn't raise, so I'll try to keep it simple. This is not a keyboard talk, though. It's a plot twist. Anyway, so my talk here is basically on CoryDora, which is a Macropad that I built. And I'm here to talk about the supply chain, and I'm going to make a case for local manufacturing. Okay, what does that mean? My goal for this talk is by the end of this, I want to make an argument, and I want to convince you guys that you should support local makers, and you yourself should start making stuff and selling it locally, right? So my goal for this talk is to convince you guys of this. I'm going to use my product, which is CoryDora, as an example, as a case study, and then we'll go forward. So what is CoryDora? There's a lot of words there. Fully open source, QMK compatible, RP2040 based, 3x3 Macropad. What is a Macropad? It's an additional keyboard with X number of keys, right? The X can be 3, 2, 1, doesn't matter. It's an additional keyboard of sorts. Okay? This is the CoryDora. Okay? Like I said, it's fully open source, 3D printed, QMK compatible, 3x3 Macropad. What is QMK? QMK is just a open source firmware for keyboards. Think of it as the operating system for keyboards, which is open source. So the Linux for keyboards. Only with, anyway, yeah. And then the RP2040 is just the brains of the chip, the brains of the CoryDora. Okay. I just want to very quickly touch upon how I built it, right? As most projects do, they start on a breadboard, though there's no breadboard here, right? And then you design a PCB. This particular PCB is from a service called JLC PCB. They're from China. They're an extremely good service. They're one that a lot of, okay, by show of hands, how many hardware folks here are people who build hardware? Okay, that's a sizable amount. Okay, so JLC PCB, I'm pretty sure you guys are familiar with. They're a very good service. Their price point is really good. But what's happened recently is that the government has imposed taxes on PCB imports. So what that means is a bunch of Indian companies got together and basically complained to the government saying, we can't compete with Chinese PCBs. Not the fully built stuff, just the PCBs. And the government, in its infinite wisdom, put I think 30% tax. So what that means is me, as a local maker, just someone trying to build a project, have to now pay 30% tax. And here's the really funny part. The 7 or so local PCB manufacturers who asked the government to put the tax on the PCBs won't even answer my call. They look at me and they're like, "Che, go." Like I'm not even worth their time. So it's like, it's funny actually that this one decision kind of ruined a lot of opportunities for makers like me. But before I proceed further, right, I just want to say that the problems I'm going to be talking about, the case I'm going to be making is, I would say for folks like me, low-level guys who make low batches of products and sell them, while I believe the problems we share is similar with, say, someone who works at a company that sells like 1 million units or something, while I believe the problems are more or less the same, I think the scale and the intensity of which they are more like a more pro company might face is slightly higher. But I believe the problems are still the same. Yeah, and then the last thing is put it in a case, but yeah. Basically, it's pretty simple. Make it on a perf board, any hardware product, make it on a breadboard, get it right, and then make a PCB, and then once the PCB was put in a case. Pretty simple, and this is the end product. Okay, I'm not going to talk too much about the CoryDora. You guys can come to the booth. I'll convince you guys to buy one there. This is the CoryDora I have, right? This is actually a very old one, 1 year old, but it still works fine. It's fully open source. It's QMK compatible and VIA compatible. VIA is a way for you to go configure these things, right? This is a Macropad that you can do a lot of stuff with. And I have a lot of folks who've used this for like stuff I haven't even thought of before. That's just another color we offer. So initially, Amit and I, Amit, myself, and a bunch of other folks run Absurd. We're a maker collective where a bunch of makers want other people to make stuff. So one thing I like to do is when we organize events, I like to give just PCBs or something to folks so that they can go build it. So CoryDora initially started off as just some simple soldering thing that it's a simple project that people can learn soldering on, right? That's why everything designed is through hole and everything. So the whole purpose of this was never meant to be a product. It was just like something I meet someone, I give it away. In fact, how many here have received a PCB from me? Okay, 4, 5, okay. You guys want more, come to the booth, I'll give you one for free. Though make sure Amit is not there because he doesn't like it when I do that, right? Anyway, that's the whole point. Like I had no intentions of selling this as a product or whatever. This was just something I meet people, I give it to them, here, go build this. But what happened is over time I took this to places and I would give it out to more and more people, right? A lot of folks were like, Balu, I want this. I want this, I want this. And I'm known as the keyboard guy in this community, which is not something I wanted, but it was something that was put on me. So once people found out that I'm making this thing and more people wanted, and some were even willing to pay for it. So around the same time, actually the same time last year, in IndiaFOSS 2024, I put out this tweet that just said, I'm going to make a small low order batch of 10 units. Anyone interested, come. Expecting no one is going to come. This thing sold out in like the first 2 hours, right? Not only did it sell out in 2 hours, we had guys come to IndiaFOSS just to buy this. They bought the ticket to the event, bought 2 CoryDoras and left, right? So this was an experiment for us in many ways, because at around the same time, Amit had this idea of starting a platform to sell products, right? Because up until now, we were just a community that were building stuff. We were not really doing anything from it, but we really wanted to do something. And this was a great incentive. Amit was working on a couple of products. A bunch of other folks were working on a bunch of products. So the timing of everything worked out well. By the way, not to mention, CoryDora was not the only product we sold in IndiaFOSS last year. We sold a bunch of other products as well. All of them are available in the booth. So last year we started off, I think, with 3 products. I'd say 3 products. And it did well, actually. It did quite well. We sold them all out. And after we sold them all out, people were still coming and asking us, we want to buy this, we want to buy this. So Amit, I think Shrest, spun up the most sketchiest pre-order page in the world. And people still paid, right? We told them we'll ship it in 2 months. They still paid. They gave us money. And my brain could not comprehend that, right? It's the sketchiest site out there. People still gave us their money to buy this. So at that point we were like, okay, this is maybe something we can do. Up until now, I was very skeptical. Who's going to buy this? Okay, 10 units, fine. It's just the crowd and maybe the people here know me, so like, okay, fine. But once I saw that the pre-orders were going, that's when we kind of realized, okay, we're going to maybe we should give this a shot. So not only CoryDora, but across all the products we had, we kind of seriously worked on them. We kind of pushed the pre-orders a little. We got more orders, put them out there. And CoryDora has shipped to we have 27 states, right? I think CoryDora has shipped to 13 states. There's someone using CoryDora in 13 states in this country. Oh shit, I should have put the screenshot here. I actually have an order from Costa Rica. A guy somehow found this in Costa Rica and reached out to me and it's like, if I pay for shipping, can you send it to me? So Amit and I are currently working out how to send this to him. But the community response to CoryDora is great, where we have a guy, Rishi. He's a he's a gold something. He's like a guy that accounts gold. I don't know what he does. It's very sketchy. Not sketchy necessarily, but I don't understand it, where he uses Tally a lot. So he bought a couple of CoryDoras, and this guy knows a little bit of Python. He wanted more. So the CoryDora has 4 layers. What that means is you see 9 keys here. When I press this button, these 9 keys behave differently. Meaning in layer 1, this is 1, 2, 3, 4, 5, 6. When I switch to layer 2, this becomes A, B, C, D, right? So I have 4 layers, so that 4 times 9 is, do the math, right? So what this guy did is, he was not satisfied with that. He modified the firmware to have 128 layers. How he remembers that many, I don't know, but he did that, right? And he's Tally, this is for Tally, right? And yeah, Shrestha over there, he gave a giveaway. We had a bunch of community support who bought 4 CoryDoras, and they were using it for a lot of great uses. Anuj was just telling me that Anuj was another early supporter for the project, and he was telling me earlier today that his friend was using it for like PCB designing and such. It's all like awesome for me, right? And that's where we are right now, which is you guys can go to shop.absurd.industries to buy your own CoryDora. Not only CoryDora, you can use it, you can buy a bunch of other products that are made locally in Bengaluru that are fully open source, and you'd be supporting the local maker movement by purchasing stuff here. Okay, so let's play a game here. I spoke too much about CoryDora. Let's come back to the case here, the actual goal of this, which is making a case for local manufacturing. Let's go through one by one, and you tell me where that part comes from. Okay? The white case, where do you think that comes from? Okay, 3D printer. Where? Home? Anyone else? China? Okay. Okay. Screws, where do they come from? China, okay. PCB, China. The microcontroller, the electronic parts, China. Switches, Japan. Right? And the keycaps, Vietnam. Right? But regardless, right? The word India is not here. Right? I mean, sure, I 3D printed these in my house, so I mean, you could technically say the cases are from India, but where's the machine from? Right? So that's my thing, which is, why the hell can't we do this in India? Right? And turns out there's a lot of reasons why we can't do this in this country. So, you hear a lot of people say, make in India, make in India, make in India. The problem is everyone expects, in order for you to have a thriving ecosystem of makers building stuff, you need the makers to be able to go buy stuff, buy parts, okay? The hardest part of building hardware in India is finding hardware in India, right? Because everything I have to order comes from abroad, right? Now because I'm a low order hobbyist type guy, I have to wait like 3 weeks for like an order to come. And even if it's a company, it's not any better, right? 3 weeks becomes like 1 week or something. But the turnover is still there. The parts are coming from abroad. So your time to, like in software, we're very used to like 1 day, 2 day type stuff, where you can go from I have this idea to, okay, it's deployed in like a day. That is unheard of in hardware, right? If you guys can do something in that space, man, you guys are making a lot of money. But that, unfortunately, is not the case in hardware. In hardware, it's just time. Everything is time. Like, my point here is make in India and find parts in India are 2 completely different challenges, right? And we'll go through them one by one. So, some of the problems, at least with CoryDora in particular, but I think this applies to the grander scale of things is, like I said before, no small scale supplies, right? The PCB guy won't even talk to me because he won't do my 10 orders. He wants 10,000. And I think Kiran made a good point as well with Misumi, which is they don't do small orders. You need to like have a certain threshold, and most people can't meet that threshold, right? And because most people can't meet that threshold, the access to materials that I have is extremely limited. So I'm kind of constrained by the things I can do. Now I can either spend a lot of money, get it, but like Kiran said, right? He has 15 excess units, right? That's not something a lot of folks can absorb if that doesn't work out. Limited access to basics, it goes back to what I said, right? Parts that are commonplace elsewhere are impossible to get here. Switches, the Macropad switches are next to impossible to get here. If you go to the Absurd booth, right? If you go to the booth right now, I can sell Gatron browns and reds because blues are out of stock throughout this whole country. I have been looking for it for 8 months. I could not find another vendor in India that has blues. Whereas I went to Malaysia 2 months ago. I bought enough. There is so much stuff there. I could just walk to a keyboard store and buy as much stuff as I want to, right? Again, access to basic parts. And then the last one is we're still dependent on China. right? I really wish I could do the Donald Trump China thing. I really wish I could like do it in that sound, but anyway, whatever we do, China is like the big brother. It's always watching over us. It's like Sauron, right? Always watching over us. We always have to go through China somehow to get our parts. But here's the thing. Parts, like I said, make in India and finding parts in India are two different things, right? Everything I spoke of earlier was about parts, right, and challenges associated there. But when it comes to actually making stuff, right, here's the thing. Having access to the machines is just not enough, right? You need people who know how to use this machine. If I bought a 3D printer right now and put it in front of you guys, how many of you guys can actually operate it, right? So that's like a very important aspect, and this is why China is winning, right? I think it was Tim Cook who said that in China, they can fill entire football fields with folks, like with CNC operators, injection molding, like those kind of really specific, really specialized skills. China has enough people there to fill entire stadiums with, whereas most other countries, that skill has just evaporated off, right? And this is why China is such a dominating power in the manufacturing thing, which is, it's not that they don't have access to tools. They do, that is an important factor, but it's the human aspect of it, the knowledge associated with it, which is why it makes beating China extremely hard, and us to get there as well. And a very important thing you need to note is factories don't just make products, they also make the know-how to make the product, right? If you are a company that, say, makes, you know the old school telephones, right? I forgot what you call the telephones. They were probably made from injection molded plastic, right? So if you're a company who knows how to make that, and say made that for 20 years, and then cell phones become a thing and now your phones are irrelevant. It's not like you're closing shop, right? The wealth of knowledge you've built with injection molding this part, you can just move on to another industry. You can find a new avenue and start selling. Maybe you can start injection molding phone cases or whatever, right? So that's what I'm saying, right? Factories once built don't necessarily just fizzle out, right? The know-how that you've accumulated building it actually compounds, right? Now, why local manufacturing matters. You guys know the Evergreen incident that happened, I don't know, last year or something, right? 2 years ago, right? Some ship got stuck in the Suez Canal, and the world went to shit, right? And I think, Trump's tariffs is another thing. One guy just, Trump imposed tariffs on everything for no reason, I guess. I mean, there is a reason, but whatever. I'm not getting into that. And now that's causing global mayhem everywhere, right? And similarly, I think there was another thing where a sudden burst of locusts in Africa led to global wheat prices fluctuating, right? So things you cannot control can have a bigger impact in your economy and all of those things than you think. And I think Evergreen incident was a great indicator to that. So I just have 4 reasons to why I think we need to build locally and push locally more, which is, first one is the resilience. I think everyone, through COVID, I think COVID was a great indicator that showed us that our supply chains are extremely fragile, that even the simplest things can ruin a lot. And I still think a lot of countries are still recovering from the after effects of COVID, right? So by having a very local economy, by having an economy that produces a lot, we are actually we safeguard ourselves from any potential, for example, Trump's tariff, right? If America goes apeshit on us again in the future, we are a little bit more protected there, because if the recent tariff things is, he wanted to flood India with American agriculture produce. Now India was able to push back because we are an agriculture superpower. We produce enough agricultural goods in our country that we can push back on that, right? And we just need to, it's the same idea, but for manufacturing, which we are tremendously back in. Creativity. Again, we need folks like us, the large scale and then small, to have access to tools, parts, everything, so that they can build stuff, right? Every large company you can think of started off as in a garage with 4 or 5 guys working on it, right? And that needs to happen. and you need to support that, right? With this stuff like, this JLC PCB, the import, the taxes on PCBs and all that just makes stuff like this extremely hard to do. And it's a very, like when I hear politicians say make in India and they push for manufacturing in India, and then I see them do shit like this, it's like, what is this? It just makes my blood boil, which is, they don't understand the ground realities of these things. And like my business was doing well, getting PCBs from JLC. I've been ordering from them for like 10 years now. And then the sudden thing comes in and I'm screwed, right? So that is there. Community, like I said, if you have access to the job, if you know the tools, if you have the local thing. My grandfather was a machinist in HAL. He left HAL, started a machine shop. He started a construction business. Again, he's just a grade 10th diploma holder. Went to trade. I mean, he didn't even go to trade school. He just somehow picked up how to use a machine, like how to use a lathe. And through that knowledge, he started his own machine shop. He started his own construction business. I like to think, it's a result of that where, my strong desire for engineering, my love for engineering comes from there, right? And not only that, it's like, again, you can trace my uncle, my father, everyone, right? It's this whole circle of things that happen. And I think that's why, are you guys familiar with Detroit? Right? It's the state in America that was extremely, it did really well during, I think for cars, right? The automobile industry was massive. So when the automobile industry was doing good, Detroit was just, the people there were swimming in money. The local economy was good, everyone was doing good. But then when automobile industry dropped, Detroit is now in like poverty, right? So local manufacturing can uplift entire communities. And then the last thing, independence, like I said, right? We don't have to always rely on China. If China decides to go apeshit on us like America is right now, we are a little bit more protected, right? But here's the thing. One argument people will make is, but locally made stuff is more expensive. It's true, right? Locally made stuff is more expensive because you're paying a premium for resilience and independence. Now, this sounds great to say, right? But will someone be willing to pay $300 for a shirt that they can get for like $60 shirt, I think okay, let me change. Is someone willing to pay $300 for a shirt that they can, $1,000 for a shirt that they can get for $300, right? I don't know how to answer that, to be honest with you, right? I don't know how to answer that. All I can say is I believe we do need to support local makers, right? And consumers need to buy locally for smaller communities and smaller makers to thrive, right? So I'm going to end with some good news. Everything I said, yeah, I painted a pretty gloomy picture, but actually good stuff is happening. We have a lot of companies right now that are changing the narrative of manufacturing in this country. We have companies like Line Circuits, and there's one more PCB Power, I forgot to include them. But these are, I no longer now have to go to JLC PCB. I can get really good quality PCBs made in India itself, which is unheard of. Like this like 2 years ago, right, was unheard of in this country, right? So in one way, the import, I think the 30% tax on import PCBs was good because that enabled companies like PCB Power, Line Circuits to rise up. I highly suggest you guys try Line Circuits. If you guys want to make PCBs, it's like $600, $700. It's extremely cheap, and the quality is extremely high. We have companies like PCB Cupid that make locally Indian-made dev boards, and they offer tremendous support. They're locally made. They're built everything. I mean, the parts come from China, of course. We're not there yet where we can make our own ESP32s, but we'll get there, right? And we have and then we have communities, right? Communities like Makerville, Anuj is from Makerville, and like Absurd, where we want people to, and we enable them to like do stuff. We educate them on how they can build stuff, and then help them build and launch products themselves. Now, a little bit about Absurd, like I told you. With Absurd, our core thing is we want people to make stuff. And not only do we want to make stuff, we want you to put it out there and sell it. We want to create an ecosystem of makers and buyers. People make their own tools. People make their own shit, sell it, and then there's an active community of folks who believe in this, who buy their own thing. That's the goal we have, and I mean we have other goals. Our goal is to Amit's goal is eventually to turn Upstart into an incubator, right, where we can incubate products where okay, if you have an idea and you want to you want help, we'll help you. That's our goal. This year, so this photo was literally I think this Sunday, where we had everyone in my lab, and we were all like planning how to like for today, like IndiaFOSS, like how are we going to sell the products and everything. Last year in IndiaFOSS 2024, the same day this year, there were 3 products. Today we have almost 12. And we've onboarded almost 4, we've onboarded 4 new makers who have joined with us and are selling their products. Now, our plan is to increase this more and more, and we have guys, and we're actively reaching out to folks to get more folks to talk. If you're somebody who's interested in making your own product and selling it, please reach out to us. We'd be more than happy to help. I think Saurabh is here. Saurabh, how old are you? 20. Okay, he's 20 years old, second year of college. He's a student, right? And he had an idea he made up, and we helped him out. I mean, we didn't do shit, but like he did most of the stuff. But he's selling his own product. 20-year-old guy designed his own PCB, designed a case, got it 3D printed, figured out all the logistics for that, and is freaking selling it. And it's like doing sales like crazy in the booth, right? This is awesome. Like this is the stuff we need to aim for in this country. And Upstart will help you. So this is something that's coming soon. Amit, it's fine. It's too late now, right? One thing we are planning on doing is campaigns. Okay. One thing we found out is a lot of makers are initially, again, the thing with hardware is you need money. Hardware is hard without money. So this new incentive we've launched, which is campaigns, which is kind of like Kickstarter, where like similar to last year where we had a pre-order page and we asked people to apply and but there we asked them to pay the full amount. Here we're kind of doing this thing where we are starting campaigns where makers in our community can launch a campaign, and then they can open it up for like monetary contributions from folks. So you pay like 25% or 30% or 50% of the final price, and then upon delivery you pay the whole thing, or some model like that. We're working on that yet, and then the idea is to launch more products this way. This is coming soon. We're still working on it, but yeah, please, I don't know what's the word. Please keep an eye out on this. So anyway, finally, my point is, if this tiny thing, right, that's like nothing, depends on parts from so many other countries. It's 3, but still, you guys get the point, right? What does it say about bigger things, right? What does it say about our own EV cars, our own, I don't know, missiles, or our own defense thing, or like, you can just go on and on, right? If the simple thing requires so many things that cannot be done in this country, what does it say about larger things? I'm going to end by saying, please support your local makers, support local manufacturing, and start making yourself, right? Please, we want more people to start making, because I believe this is a circular thing. More people start making, I think we're going to have the local industry flourishing, okay? We can either stay permanent consumers of someone else's factory or start building our own, and I want us to start building our own factories, all right? Join Upstart, guys. Please join Upstart. We're an extremely active Discord community. Please scan this. Join our community. We're extremely active. Like I said, we want to help folks. It's not just me. We have so many guys. Please join Makerville as well, right? We have to like Makerville as well. Please join any kind of join. FOSS United is a great community. Please join these communities, and we can help. So if you're someone who's planning on making hardware product and need help, reach out to us. We'll help you. All right. Thank you. Thank you, guys. Have a good day. So, who's next? Anuj. Yes. Shit. I have no knock-knock joke, so we'll just move on to this. show your support. Then Srinivas is, I said, go tell him hi. Tell him he's doing a good job. Alright. We'll end it. Please come.
Okay. Hey guys, so my name is Anuj. I'm going to be talking about the Makerville badge. So I'll come to what Makerville is in a minute. Let the suspense build a little. Yeah, so about me, my day job is I write firmware for a living. I started off with Google Summer of Code. I'm sure most of you have heard of that. I did that at Beagleboard back in 2013. So since then, I've been writing firmware for a living. I worked at companies like Espressif and Balena. These are popularly known in the maker community. That's why I mentioned those. And I've been working as an independent firmware guy since then. They do a thing in movies where they tell something beforehand and then later it becomes relevant. So I'm just putting this out there that I like keyboards more than using a mouse. Right? So I'm going to come back to that later. So my work is in consumer electronics, medical instruments. I work on environmental sensors and those kind of things. So is something weird happening with the... Oh, okay, sorry. I thought I lost the screen. But yeah, my day job basically means that I work with firmware. I have to deal with hardware every day. And some of my past projects, I've done a crowdfunding project. I've been featured in Hackaday for some of the dev boards that I've built. Right? So I also like to do art installations once in a while. So I've made things like piano stairs that play the piano when you walk on them and a couple of other things. Right. So Makerville is a community of people like me whose day job is more or less working on hardware. So PCB designers, CAD engineers, firmware, people who write firmware, right? So we started this back in 2019. We started it because there's a guy called Mahesh from Bangalore, Mahesh Venkatecharan. Right, so he used to run his forum, which got closed, and I was pretty upset that it got closed. It was called Indian Hardware Startup Network, IHSN. Right, so that got closed, so I started Makerville. And that's basically just a place for people whose day job is more or less something to do with hardwares, PCBs, whatever, to talk shop, right? And then people find collaborators on our Telegram channel and so on and so forth. Right, so we are less hobbyists and we are more professionals, I would say. This is a photo from our conference, which happened last week. Calling it a conference is a little bit of an overkill. It's mostly like 15 people meeting and having food together and calling that a conference. Right, so this is the background for who Makerville is, and then we were like, okay, we guys should make a community project, which all of us at Makerville kind of use it for their day job or anything. So the obvious candidate for that was let's make a badge which we can use anywhere we go. So let me switch this. So this is the badge that we ended up making. It's a pretty simple device. It's got a NeoPixel LED on the back, so you can also add more NeoPixels and control that from there. It's got an OLED screen, and it's not visible, but there's an ESP32C3 on here, right? So the question is, why do you want to build a badge, first of all, right? Like, so the answer is that, okay, before we get to why build a badge, it's like, what features would you put in a badge that makes it useful? The first is obviously you want to make it cheap. You want to have Wi-Fi because then it can connect to the internet, download something, upload something. Bluetooth because in a place like this, Wi-Fi isn't working. I'm sure most of you have noticed that by now, but there isn't really any Wi-Fi that we can use here. A button so that you can actually interact with it, a battery, which is optional because many people just carry a battery bank, so we could use that, and optional USB-C. So let me give a quick demo and then come back to some of the features. Okay. So one of the things that we want to make with a badge is that it should be pretty easy to work with, right? Like, how many of you have set up Arduino before? Okay, so that must have been a pretty straightforward process. How many of you have set up ESP-IDF or Zephyr or a custom SDK from some vendor, right? And how painful was it, right? Like on a scale of 1 to 10, how bad was it, right? Even if you just wanted to try out a Hello World, it's typically pretty bad. Projects like Zephyr are making it pretty good so that you can have a single installation and then that works with a few dozen chip vendors, but that doesn't always work, right? So we wanted the badge to have like a very easy interface. So what we said was, okay, what you can do is you could just go to this website, say connect the device, select the device which is connected to your computer, and then just say, okay, it works. Now this just gets rid of a lot of things, especially which are needed for flashing. This doesn't take care of your development environment. You can't build new things, but there's a workaround to that sometimes people do use is you open GitHub, you can edit files there, you have a GitHub action which builds your firmware, puts it in the releases directory, and then you can just use that. Right, so if you gave me a computer which did not have any development environment, I could still use it as long as it was not Mac OS, because Mac OS does not support this particular framework. Right, so once you have this, now this device is, if you can see, because I connected it to serial, it just stopped moving. This text was scrolling earlier. But because now I'm in the flashing mode, I am it's in a frozen state, let's say. So next is we made this simple open source website which says that, hey, pick the latest firmware and flash it on this device. Right, so what it's doing now is it's going to our GitHub, which is this, and just finding out what are the latest releases, getting the binary from that release, and just publishing that on this particular device. So this gets rid of that whole Arduino setup that you have to do. If someone gives you a binary, you can just run it. Now, this is not a risky binary because this is something that will only work on something like an ESP32, but that's how this works. So let's see why. Yeah, so now it took a little while because it was initially erasing the flash, and then it should hopefully flash the firmware. So the reason why I mentioned this is that when you are making a product, you want to make it very easy for people to experiment with things. So when you give them a release, how do they, so firmware flash successfully. So when you give them a release, do you need them to set up their whole environment? Maybe not. Maybe there are better ways that we can do this. This does mean that you have to select particular chips, but I think depending on the kind of product you're building, that's a good trade-off. The second thing that we built into the web aspect of this, again, the website that you can go to is called badge.makerville.io. Right? You can start scanning for devices, and you're going to see a couple of these devices show up here. So these devices are all the Bluetooth devices in this room, right? So you can see someone's Huawei watch. I don't know if it's visible, but someone's Huawei watch, or there's a CMF Watch Pro, or then you can see this, which is the Makerville badge, right? So now, before I connect that, let me show you what's, I don't know if it's visible, but kind of visible. Yeah, okay, so right now the text that's been shown here is basically it's Makerville badge. Right, so what I'm going to do now is I'm going to connect to this device and say pair, right? It's going to take a second to connect to that, and someone say something random that I will put on the badge. Absurd Industries, perfect. Right? So if I go here and just put Absurd Industries and I say send to badge, you'll see that Absurd Industry, you'll see that Absurd Industries is what's shown on the screen now. Right? And if you go back to this page and say read data, it's going to say Absurd Industries. Right? So what we're trying to do with Makerville badge is to build these small tools around the badge. So one is to update the firmware. The second is to talk to the device over Bluetooth. so that anyone who's building anything can have like a tool chain, right? When you see this is true for, actually I'll give a better, when you see someone like a Batman, right? He has a utility belt of tools, like he's got a bunch of tools in there, he uses them together, and he always has that. So what we are trying to do is, because we tend to work on a lot of projects, we have these tools that we need on all projects. So what we are doing is we are making a badge which combines all of these tools into one project, so that becomes our boilerplate, right? The next thing that we have here is this expansion connector. So if you look here, we have this 6-pin connector. It's a standard which has a funny name. It's called SAO, which stands for shitty add-on, right? So this is American sense of humor. I don't necessarily get it, but it's basically like all badges which are open source tend to have this 6-pin connector. So if I make a small LED attachment that goes on a badge for a conference, let's say this conference, and then next year we have another, as long as that 6-pin header is there, you can connect whatever you built for a previous conference at the next conference, right? So we have that connector as well. So that acts as our interface for additional sensors, right? So why okay, now I'll answer a little depth about why build something, right? Like the people who built this badge are people who do hardware for a living, right? Like they work on PCBs, they write firmware. This is, if you are from that world, you would realize that this is not really a complex project, right? Just some tech spec, it's like a 2-layer board. It doesn't even have any sophisticated wires that are needed. The components are all such that you don't need anything high speed, right? So it's not a sophisticated project. So why spend time building it? Why spend time writing firmware for it? And the answer is that it becomes the boilerplate for anything that we want to quickly do, because talking over Bluetooth is something that we need every time. Flashing firmware is something that we need every time. Let's say I have a customer here, I have to send that device to him. He's not going to set up Arduino, or he's not going to set up Zephyr, and then I'm going to give him updates or anything like that, right? Like he needs something simple to do that. So having those kind of tools ready helps. So it becomes a boilerplate for us to just say, okay, just copy this into a new folder, start that. It works as a dev board. Sometimes when we want to do a quick prototype, it works as a dev board because it has some pins that were broken out. And even in its simplest form, it is a useful tool, right? It is a display connected to a microcontroller. Now imagine I'm working on something which does not have a display, does not have Bluetooth, does not have anything, but I send it to the customer and there's an error. How is he going to tell me what error it has? So having a tool like this really helps, because I can connect it in addition to the hardware that I've built, and then show on the display that, hey, this is error number 3256, which means something internally, but that's something that they can send us. Now I'll talk a little bit about the tech. The tech is not that difficult. So basically what we have is, okay, let me open this. So we use KiCad, and the reason why you use KiCad is it's open source. It has a great community behind it, and there's a bunch of Python tools that help us. Right? This actually slide is just the same slide for the next, which is about Zephyr. It's like open source. It's got a great community, and it's got great tooling. Right? So that's why we picked KiCad for the PCB. That's why we picked Zephyr for the firmware. And yeah, let me quickly show the PCB. Hopefully it opens fine. Again, the license for this is CERN version 2, I believe. So anyone is free to open it and make changes to it and do whatever. Right, so this is how the PCB looks. One thing that we also did was we tried to use as big components as possible. So this particular device is machine assembled, but if you see, the resistors and capacitors are quite large. And one of the reasons for that was also so that we could make a kit out of it. So people can, if something goes wrong, they can fix it on their own. The other thing that we did was we tried to keep USB-C as a separate module so that we can kind of keep the cost low. and then it becomes a device that you can just use and forget. This is the SAO. I don't know if when I was showing the video earlier, if it was clear, but this is the shitty add-on connector, this 6-pin, that is a very common international standard. I mean, it's not an international standard as BIS or IS or those kind of standards are, but it's just a standard that hackers who make badges use, and you can kind of use based on that. The 2 pins here are also a battery connector. So I would love to show you this in person, but this is just, I can zoom in on this, but this is our battery connector, so you can just connect a simple AAA battery, 3 sets of AAA batteries, and you should be able to use it. Plus, all of these headers are the ones that we were not using that we broke out, so that if in case you need more things, you can add to that. So, yeah, sure. There are some drawbacks to what we did. Yes, it's very useful to scan for Bluetooth. It's very useful to flash a USB device from your browser. A browser is ubiquitous. It's everywhere. But there are some constraints. For example, if you're on Mac OS or iOS, both of these things won't work. You have to blame Apple for that. There's no other way around it. But anyone on Windows or Linux will work. Surprisingly, Firefox also doesn't work, which is strange. I can understand why Apple would do it, but I don't understand why Firefox would. And that's the same with Web Bluetooth as well. These are pretty good tools, I would say. There's a lot of open source projects who have benefited a lot because of that, because this just eliminates all the steps required for please install Arduino IDE, buy an Arduino, flash the firmware. It just gets rid of all of that. Right, so I would recommend that if you are starting an open source project, or even if it's not open source, it helps, because when you're talking to customers, they're not going to set up a development environment unless that person is like a very technically savvy person. That is more interesting. I would please send me the link. Yeah. So unless that person is unless your customer is like an extremely tech savvy person, which there are many, right? They're not going to do that. So try to set up these things. The last part, I showed this earlier. So we do have a case for it, and it's 3D printed case, of course. And the way we did it was we decided to write code for it. OpenSCAD is something which works well with FreeCAD, but it's basically, it has, I wouldn't say a rich library ecosystem, but it has a pretty solid library ecosystem. Why I like it is because I'm trained as a programmer, so my mind thinks like one. So when I have to use a mouse to design CAD, it feels a little uncomfortable to me, but if I'm writing code, it feels much more natural. The other good part is that I can reuse code from different projects very easily. I know this is not like, if there's mechanical engineers, they're all hating on me right now. But this does work well, especially if you're a programmer, right? Like you can, at any point of time, you can say, okay, I'll stop using code for writing CAD and then import it in FreeCAD and then start using a mouse, right? So that's the last bit of the puzzle. So we kind of made this design. It works pretty well. The idea there is that, we can have cutouts in case we decide to have more hardware in there. But this is the most minimal version of the case. The other good part about using code for CAD, this, by the way, fits into my first slide, which says I like using a keyboard more than a mouse. The other good thing about this is that you can use AI. I don't know where we stand as a room of people on using AI for doing hardware, but AI does OpenSCAD pretty well, I would say. It's a limited spec, like the language is not too vast, there's not too much code for it, but you can prompt Cursor or Claude to basically make an enclosure for you, right? You still need to make sure that it did what you asked, which is true for any AI evaluation, but this works pretty well. So in case you are an amateur CAD designer like me, maybe you should look into writing code for CAD. But yeah, that's it about Makerville badge. You can go to badge.makerville.io, you'll get all the tools that I showed. I would say even if you're not making a badge or buying a badge, I don't even think we have it available yet, but using the flashing and WebBLE tools is a pretty good start. when you are making your own project. You can just fork the project that we have and start using that, because that gets your device faster into the hands of customers. Right? Your firmware doesn't need to have OTA and all of those things ready before you ship it to customers, because you can always say, hey, just go to this page and flash firmware and you should be good to go. But yeah, these are the URLs. Feel free to check it out. And yeah, that's it. Any questions? Yeah. Yeah, so the badge ecosystem is basically, IndiaFOSS is not hardware heavy, but like there are hardware heavy conferences that do happen around the world, right? Open Hardware Conference is one, right? So then people are like, instead of giving a badge like this, let's include something like this, because, okay, so to give an idea, this probably costs 350 rupees to make, right? A little less if we do it at scale, right? So it, yeah, C3 is 170. The display is around 80 to 90, right? Then the third biggest expensive component is probably the USB-C, but then we said that's optional. Even if you use it, then I don't think it will cross 350, right? So, and yeah, I mean, this is like a fun project, so this is not going to be a money-making thing, but like, even if you added a thin margin, 500 rupees is fine. So a lot of conferences decide to give something like this, and then you would basically have a way to customize what is shown on the screen, or they would put your name on that and give it to you. So this has been going on for quite some time. In fact, this guy who did this PCB as well is called Anuj, the guy in the blue, right? He was one of the first ones to make like an e-paper display back in 2012 or something like that for the Open Hardware Conference, right? So the thing is that it's become like a cultural thing to make more and more absurd badges every year, like which do a lot more with very little hardware. So that's why. And then what happens is people kind of build, how you have Arduino shields, Raspberry Pi hats, people build add-ons for these badges. So it's culturally expected of you to put that 6-pin header somewhere on your badge, so that, you know, if someone uses a badge, it's like in their collection it fits well, basically. There's no there is no hardware conference. Like I said, right? Like this is a photo from the Makerville conference. But that's more of an unconference. The nature of that conference is that we don't have any structured talks. People just come and talk about what they've been doing in the last year since we met, right? So there is Makerville unconference that happens. Hopefully Absurd and Maker will make a larger one soon. But this Devroom is a good start, I would say, definitely. I think this is the second time this is happening.
Yeah.
Yeah, this is.
Our second collaboration with Boss United. We had one earlier last year. That was a much smaller one, but yeah, more.
Yeah.
Hopefully, so next year maybe Upstart and Makerville will do something.
Yeah. But yeah, there's not a lot. Hopefully, there are more. Meetups are common. I do conduct some meetups on Saturdays or Fridays, sometimes in Pune. The most recent one was with collaboration with Zephyr, which is the real-time OS stack that also runs on the bed. But yeah, hopefully more of this.
Shout out to that. Upstart does monthly meetups. We usually go to someone's lab. So that's like, I mean, I say lab, right? Where it's usually like a room in our places, right? So usually my place, Amit's place, or we have other folks. Every month we just, rather than worry about venue and all that stuff, we just go to our lab. So we go to each other's houses, we just sit there and then we build. This Sunday was a great example where everyone were in my lab and we were just building stuff. And sometimes we have very formal discussions on stuff. So if you are in Bangalore, join Upstart and check it out.
Yeah. For very obvious reasons. I think the hardware communities in India are regionalistic. I don't mean to say that in a shrewd way, but like Makerville is mostly Mumbai, Pune, that side's Gujarat, because we tend to meet in person, right? And yeah, like there's a few communities in Kerala as well, right? There's Jitin coming tomorrow. He's going to have a talk. You can, if you want to talk about communities in Kerala, you should definitely pick him. So like Hyderabad again has T-Hub and that ecosystem. So because hardware is more of a physical business, communities are also, you know, spread out like that. Makers Asylum in Goa is another example. There used to be Makers Asylum Mumbai, so anyone in Mumbai would 100% know about who's Makers Asylum. But then since COVID, they shifted to Goa, so they're now Makers Asylum Goa. Any more questions? All right. Thanks, guys.
Like I can hear someone saying Malayalam or something from behind. Yes, yes. Okay, nice. Okay. Hi people, I'm Rishi. I'm Rishi Krishna. I'm doing my third year computer science at CUSAT. It's basically an engineering college based in Kerala. Okay. So my product is known as Engota. Okay, so basically product or hardware product. Okay, great. So product is known as Engota. Engota basically Engota in Malayalam means where to, like where are you going? That's basically what is Engota. And as you can see here, that's our logo. It is designed by my roommate. Even he is really good at designing logos, and that resembles that A you see, right? That in Malayalam first letter A. Yeah, that is A. And that navigation, like Google Maps kind of icon. Okay, I don't need to say Google Maps, now it's proprietary. But basically that location icon and scooter thing, like that holding thing. Yeah, this is basically spoilers. I'm going to come to what I'm going to say. Wait. Okay. So as I told that I'm studying, I'm Rishi Krishna and everything. The thing is, I like building stuff, right? Like whenever I see a problem, like whenever I see any kind of problems which is surrounding me, I like to solve it if I can solve it. So that is basically me. So this is basically a link to my GitHub repo, and you can find the Engota repository there. I believe it might be empty because there is a guess who actually made the Google Maps API public? Me. Yeah. So yeah. So I actually got a mail from GitHub. I was like, yo, what the hell? You just made the API public. Like, what is this? So I just deleted that. I will just push everything into that again. Don't worry about that. It's still open source. Okay, now another two sets of cool people who help me build this, like Roshan, he do all the website and stuff, like I'm really bad at web, and Jamshia, she's really good at building PCBs and everything. So yeah, before starting this, I want to give a huge thanks to Tinkerspace, okay? Tinkerspace is a maker hackerspace based in Kerala. So we have a stall here, there, like above. You should actually come visit there. It is really nice. So the thing is, this is the thing. Like I still haven't told what this is. Like this is the thing, and I made multiple trial. Like basically, this is the product of trial and error. By multiple, I mean I printed a lot. Like Korean chutney is right there, and I took some really, like this is I only added 4 of the photos. I believe there are 8 more failed prints. So anyway, at the end I got this. Okay. Now, rather than all the blabber, let's come to the problem. Okay. Shit. Oh. Huh? Oh, wait. Okay. So the thing is, how many of you ride bikes, scooters, and everything? Okay, that is a really nice market. Okay, in this, how many of you like? Okay. Uh, okay. So in this, how many of you like mount your phones on the bike? 1, 2, 3, 4. Okay. Okay. Good. So the thing is that with this, like when you mount your phones on like bikes, there is some issues with that camera, like the camera. You know that, right? Have you experienced it? Anyone have that experience before? Yes, thank you, someone. Okay, like I shouldn't thank, but anyway. So okay, so that is a really bad issue, right? So that is one of the reason why I don't actually mount my phone into the motorcycle. So yeah, I don't do that. So I was like, but the thing is, I want Google Maps, okay? I want Google Maps. Like, some people actually put the headphones, right? Headphones with Google Maps and things. But the thing is, well, like while wearing helmet, I don't like wearing headphones too. Like, it's bad. So that's why I created this small device, okay? So what it does is it just basically shows where to go. Like you could connect your phone into this one. That is a really cool story. Like we are coming to that. I'm telling a lot of like that was I was gonna. Okay. So basically what it does is you can connect your phone to that and just give a from and to location like same as in Google Maps, and what it gives you is a turn by turn navigation, like 200 meters and you got to go left. Yeah. So the whole reason I did it because of the issue. And the next thing is I don't like mounting my phone, whatever. Okay. So yeah, that is the PPT is a little bit brushed up. That's why the okay. So let's talk about how I built that, the software, right? So initially, I thought about scraping data out of Google Maps, like rather than using the API. So what I did was built a small app. Like what I tried to read from the notification. Like I believe there is some kind of plugin via which you can read from the notification. So I built a small Flutter app. Like Google Maps actually gives the notifications, right? Left turn, right turn, and everything. I actually try to read from that. But the thing is, they don't update it like frequently. There is little frequency. I mean, the update is really less frequent. Then what I did was I made a companion app. So obviously this is FOSS, right? So the thing is, I am talking about Google Maps a lot. So obviously we made an OpenStreetMaps version. But the thing with Google Maps is actually crowdsourced, right? So even though like OpenStreetMaps is also crowdsourced, but most of the locations are in Google Maps. So that's why we are going with Google Maps. But if you want OpenStreetMaps, we have both the versions. So yeah, that's it. So the app is really simple. It just sends the from and to direction into that. The next one is the hardware. The thing with hardware is that this was actually a bit active. Like it was working fine in the morning. So then I couldn't figure, like the battery finished. And guess who didn't mount a like printer, like give a hole to charge? Me. Like yeah. So one more print, I guess. So the hardware I use, the hardware is basically an ESP32, the display, obviously, RTC. Like basically, if there is no Google Maps, like you just want to go somewhere, it will just show the clock. So you know what time it is, obviously. Yeah. Okay. Next, the batteries and the PCBs and everything. So that is the hardware. Yeah. The thing is, I planned on showing the UI on this one, but there's that. Yeah, so this is how it should look like. It will just show the direction and how much kilometer, I mean how much distance is there to like turn or something, and how much time is remaining and when you will be arriving and everything. It's a really simple thing. And obviously, we modeled the entire thing in Fusion 360. Obviously, the thing is, I know Fusion 360 a while back. That's why I haven't used FreeCAD. Like a lot of proprietary tech in this. Like, yeah, thank you. Eh? Yeah. Yeah, exactly. Yeah. The thing is, okay. I mean, at a FOSS conference, it is a really hot take. Okay, but anyway, the thing is, everything is there. Like did this in Fusion 360. It is pretty nice. And yeah, the thing is, it is really early stages in development. This is not how it should be looking like. I mean, this is how it should be looking like. But like this is basically 3D print, right? We could improve that. So if you guys want to contribute, it is the repo is like I send that first link, right? It's just basically Angota. As I said, this would be a empty repo. I would be updating this right now. And the app is there, so you could actually view that. The app one. The thing is, one is aesthetics. The next one is like if you see, like if you want to go left, right, then after that you want to see what is the next. So you just want to like you could like see the next thing. Okay. And there is a switch too. The thing is, I didn't know that rotate encoders had switch. Like this is the first time I brought that. Then I was like, okay, like I want to give some functionality to that. So. Okay. A bit of technical details. We are using the ESP-C3 Mini. Yeah, ESP-C3 Mini. It has that flash, right? So what? Oh, okay. Like one more technical stuff. What we do is actually we store the direction icons, right, in the flash. Like there is that. What is that? ESP differ. What was that? Yeah, SPI. Yeah, like that file system or something. SPIFs. 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 Right. Yeah, SPIFs. Yeah, we actually use SPIFs to store the directions, and from the smartphone we just take that turn left or right, then we just actually view that. That is actually how it's done. So yeah, that's basically a really simple project actually. Yeah, any more questions or anything cool? Yeah. Yeah, they do, yeah. Yeah. Uh, sure.
Offline maps, right? Like especially when I'm going somewhere and
Oh, that is one of the greater advantages with this.
Yeah.
Yeah. The thing is, the thing is like, I too don't like companion apps. Yeah, that's why I tried to scrape it off from Google, like Google Maps itself.
I want to try that too.
Yeah. But the thing is, it's obviously Android. It's done by Google itself. They are really like, it is really hard to get some amount of data from it, like, or you have to be a really good programmer, or I am a really bad programmer, because I can't get much of data from it. But like I'm actively trying to do that. If I try to, if I get that, obviously this companion app won't be there. That the next thing is that roots thing, right? That is actually nice, because that is another issue. Like if I like most of the time I think my phone is dead right now. Yeah, it's dead. This is the issue. So the thing is, like initially, if I set the map, everything is actually like the whole entire thing is in the flash itself, like commands and everything. And polyline is done in like right now. The polyline is done from like right. No, I just found an error right now. Sheesh. Yeah.
Okay, just one more quick thing. It's more of a sorry. It's more of a usability thing. Let's say you have that 300-meter turn left. Right?
Yeah.
Sometimes what happens is 300 meters turn left. The next direction is 10 meters turn right. So I had like 300 meters. I turn left, and suddenly it's like 10-meter turn right. I'm like, oh fuck.
What?
Because I don't have enough time to turn right, cross the road and turn right. Yeah. Prepare, that's the experience. Yeah. So if you can see the whole bird's eye view, or like show the next two directions, then it will be helpful.
Yeah, like to be honest,
that's one more reason I wanted to hack the Tripper device.
That's actually the reason why there is a knob. Like you could actually check out the next direction, like by turning.
No, I mean knob also I have to take my hand off the.
That is true.
Like just the next.
Yeah, like
one or two. Even if you show it like in a small.
As Balu, like some kind of prefetch or something would be there. That would be also nice. Yeah, someone from was there.
So it was not clear to me if it's this, like, did you make it work with Google Maps or not? Like, what is the split?
Yeah, I kind of did, but it was really not accurate. Like Google Maps rarely updates that directions thing in notifications. So like even if I get it from notifications, there might not be like
And
some specific.
do they not provide like an API for
Yeah,
this?
they do. The whole thing is to do this for free. That's the idea. Like not paying for the API.
Okay. But if you do with the API, there is an option to do it.
What?
With the API, it
Yeah,
will
with the
work.
API it's really fine. Like
Okay.
with the API it's really fine. It's really easy.
I have a question. How the hell are you mounting that to the bike?
Yeah, the thing is, I was wishing no one would actually ask this, to be honest.
So you guys fail at the most basic.
Yeah. Like once I designed, I was like, okay, how? Like I can't hold this in my hand, right? Like to be honest, like while showing this, I was like this, right? Because mount would be there in the backside, obviously, but right now, no. yeah. Yeah.
So, how much does the battery last on an average when it comes to this?
Like for 6 to 7 hours, it's pretty fine. I think like if you do the calculations, it's like 14 or 16 hours.
So, do you use a color display for this or a e-ink display for this?
This is actually a color display. Like this is the one I actually got and yeah.
Because I actually go out on long rides a lot. I live in Delhi, and my last ride was, I think, last month. I went to Shimla Rotang for the entire landscape.
Oh, sheesh. That is really cool. Oh, they actually use that. That is really cool. Yeah, I have to check on that. Yeah, about this one. Yes. Battery, yeah. 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 That would be like the practical approach would be that. Yeah, that is actually that's one thing I thought. Like Royal Enfield don't actually draw the power from the bike, so I could actually add a terminal or something in the behind. Like I could add a terminal. That is actually cool. Yeah. I mean, yeah. Yeah, legally it would be really bad from scraping from Google, I believe. That is true. Like Kerala police is really good at that. Yeah.
So that's one question. Another unrelated question. Will this help me if without internet? Like, will it be able to, let's say when I start from my house and I go somewhere 300 kilometers out there,
But
suddenly there's no internet, right? Like I'm kind of like navigation is suddenly like, hey, Tripper is like no internet.
Yeah,
like,
the thing is
did you not like cache the route or something like?
Yeah, the thing is right now the only thing for routing is that your phone should be on. Like the thing is, it doesn't have an inbuilt GPS or something, so it gets the data from phone. But initially, if you get the route right, then it's fine. Then you can turn off the internet and everything.
So what I mean to ask is, does your companion app store the route offline?
Yeah, we store the route
through
offline.
the course of navigation. Okay.
Yeah, exactly. Yeah.
Okay,
We do all that stuff locally. Yeah. I don't. The thing was while I was building this, I didn't have GPS at hand. Then I was like, no GPS. That was my whole thought process actually. But like having GPS is pretty cool.
No, but
yeah, that phone GPS is there. That is also there.
Gagan.
Answer for that. So if you're connected to the phone throughout, you don't have to be connected to the internet. Phone will give you the GPS, and if you have the companion app, you can compare the current location with the stored data on the companion app. Because even Google Maps does that. Like Google Maps caches the whole route.
Yeah, like even if another like the API call would be done again if there is some rerouting or something like that. Other than that, yeah, call again. Yeah. Oh, okay. Thank you, guys.